I think we're at least 2/3 likely to be in a simulation. I base that partly on how close we are to getting to be able to build realistic simulations ourselves. But if we show it's possible, someone's probably already done it. The universe is a kind of hoax. Given my background as a computer scientist, I'm trying to understand that idea of a hoax. And the closest thing that I can come up with is that the world is some kind of computation that is happening on an ongoing basis. The double slit experiment and quantum indeterminacy, both of these actually are clues that we might be in a simulation, is that they don't really make sense in a physical universe. I'm not saying that we're running on, a Windows 10 or 11 computer. The computation that runs our universe is most likely a quantum computer. There may be this possibility of conditional rendering with a phenomenon that's as complex as the UFO phenomenon. And what that means is some people might be able to see them and other people may not be able to see them. There's also this possibility that they are presenting themselves to us as a technological phenomena, but that may or may not be their actual form. He was suggesting that somehow there were simulators that could go back and change variables and rerun the simulation. And some people actually remember the previous run of the simulation.
Today, we're going to go through all the evidence of simulation theory and kind of talk about all the various components. And we had a great conversation last night and a great dinner last night. It's kind of always been one of those things that I've wanted to explore on the show. You're the first guest that has come on the show to explore this topic. And kind of as I was getting ready for the episode, it just became so apparent with how much information there is to support the possibility that this is a simulation. And so, I want to kind of get to that in a minute, but what got you interested in the topic of simulation theory?
Well, for me, I was an entrepreneur for many years. And during the time that I was running my first startup back in Boston, back in the 90s, I was living this double life where during the day I would be dealing with software and I would be dealing with venture capitalists and employees and banks and customers. And, we had the Fortune 1000 as our customers. And then on the weekends and in the evenings, I would be jetting off to places to explore different aspects of consciousness, whether it's Buddhist meditation or shamanic journeying using drums, not so much psychedelics, and altered states of consciousness, or to the Monroe Institute where they were investigating out-of-body experiences. So I had quite a bit of exploration of consciousness, but it was separate from my daily life and what I did, which was software for enterprises. And then when I moved to Silicon Valley, I became part of the video game industry, and we had a game that was the #1 game in the App Store. We ended up selling that company to a big Japanese public company. And then afterwards, I started to investigate virtual reality. And I ran a startup program at MIT for startups that were doing VR or AR, augmented reality, which is where you place something, over the physical world, which isn't actually there, but from the goggles, it looks like it is there, or eventually from contact lenses. But it was really my experience with virtual reality that pulled me down this rabbit hole. And so what happened was in 2016, I was visiting a startup that was in Marin County, across the bay from San Francisco. And if you've ever been there, it was in Sausalito, and there's a beautiful view of the San Francisco skyline. And, when it's not rainy or foggy, San Francisco is one of the most beautiful cities in the country. But of course, we weren't enjoying the view. Instead, they had this room. It was about the size of this room. And I put on this virtual reality helmet, and it was kind of big and bulky. And there were wires coming from the ceiling. So there was no mistaking that I was inside virtual reality. And I started to play this VR ping pong game. And what happened was that the responsiveness of the game was so realistic that I started to feel like I was playing a real game of table tennis. And it was really the physics engine of the game that was really good. So much so that for a moment, it fooled my body into thinking that I was playing a real game. And at the end of the game, I tried to put the paddle down on the table, and I tried to lean against the table. And of course, there was no table. Mm-hmm. It was all virtual. So what happened was the VR controller fell to the floor, and I had to stop myself from falling over. And that's when I began to think, okay, how long will it take for our virtual reality technology to get so good that the virtual world would be indistinguishable from the physical world? Basically, how long will it take us to build something like the simulation that was shown in the movie The Matrix, which is, of course, the most popular science fiction representation of this idea. And so I laid out these stages to what I called the simulation point. And that really got me down the rabbit hole of simulation theory. And that was after that I then started to explore different ideas in quantum physics and realized that they were telling us something similar, that the physical world doesn't really exist and it's all based on information. And then I started to explore different religious scriptures and ideas, particularly the mystical aspects of the world's religions. And I realized they were all telling us that the world isn't real as well. And so all of that together really led me to this conclusion that perhaps we live inside a computer simulation. And having come from the video game industry, for me, the subtitle of my book is an MIT computer scientist shows why AI, quantum physics, and Eastern mystics all agree we are in a video game. And so the video game model, to me, became the best way to think about this idea of the simulation hypothesis.
Yeah, it's a really good model. It makes total sense. So what percentage chance do you think that we are actually in a simulation versus base reality?
Well, so, if you think about it, if we can get to the point where we can create these virtual realities, and I define the simulation point as not just the VR world being indistinguishable from the physical world, but with AI beings inside the world that you're interacting with, then you can't tell if they're actually AI or if they're controlled by a player. If we can get there, then the idea is that someone has already perhaps gotten there, and we are already inside that virtual world. And the key is, if you can't tell the difference, then the chances are at least 50-50, in my opinion, that we would be inside one of these worlds, if it's possible to build those kinds of virtual worlds. Now, when I first started thinking about this back in 2016, 2017, AI was still pretty far off, and the virtual reality wasn't that great, and the augmented reality wasn't that great, and BCI's brain-computer interfaces hadn't gotten very far, and in the intervening years, we've gotten closer and closer to this point. So at this point, I tend to ascribe a higher percentage than 50%. I tend to say that we're probably 2/3 of the way there with today's AI. If you look at the videos that are being generated today, many of them are already indistinguishable from real actors. And Google came out with their VO3 product earlier this year, and now DeepSeek is coming out with their AI products. But they're basically creating videos where the actors will say things like, I'm not AI generated, what's called the prompt theory, which is another variation on simulation theory. Like, I'm not from a prompt, I'm real. Obviously, this is all real. And yet they're all generated in AI. And I was showing that video at a conference recently, and I told everybody, this is AI. And afterwards, people came up to me and said, was that really all AI? I said, yeah, it was. So to make a long story short, I think we're at least 2/3. 66%, I say around 70% likely to be in a simulation. And I base that partly on how close we are to getting to be able to build realistic simulations ourselves. But if we show it's possible, someone's probably already done it.
Yeah, I mean, I think we've got to get past the point of questioning whether or not it's possible to build a virtual reality like this, like the one that, like the place that we exist within. I mean, it's very much possible. I mean, and if you think about the Earth being, or the universe being around for 14 billion years, and Earth being around for just a couple of billion years, I mean, there's billions of years in there for life to advance somewhere else and to surpass our technological capabilities and to produce something that would be indistinguishable from a reality, and to trick the people or the entities within the reality into thinking that it was real. So, I mean, there's just been so much time that's gone by, and for us to be this close, and for us to be able to be creating video games with normal computers, not even quantum computers, where we have virtual MMORPGs and, virtual reality and augmented reality. I mean, of course, some advanced civilization could make this into some sort of a simulation. The question is it? Is it a simulation? And so you are at you're at 2/3 that you think that this is a simulation that we exist in, and I guess, is that correct?
Yeah, that's a rough percentage.
Yeah, okay.
I think we're in that range, and I think, to your point of an advanced civilization. I mean, computers have only been around really since the 1950s, more mainframe computers, so less than 100 years. If you give us another 100 years, where will computer technology be? If you give us 1,000 years, or you give a civilization 10,000 years,
or a million
years, and this was the argument that led Elon Musk, who made a statement back in 2016, actually the same year that I was trying on the VR headset, and he said the chances that we are in base reality or not in a simulation is 1 in billions.
And is that the same thing, base reality and a simulation, like non-base reality and a simulation? Is he leaving any room for error by like leaving things open to some other possibility for reality, or is he purely saying that that it's 1 in billions that we are not in a simulation?
So I think he's saying that it's, if you take the 1 in billions and you take the opposite to say, okay, what are the chances we are in a simulation? It's, billions to 1, basically, that we're in a simulation. And his argument was slightly related to what I was saying. And he was saying that not only would we create one virtual world, but we could create a series of virtual worlds. We could create hundreds, thousands, millions, 1 billion different virtual worlds, because all it would take would be to run a new computer system or run a new process on a computer. And therefore, if there's, say, 1 billion virtual worlds and 1 base reality, and you can't tell the difference, then what are the odds? The odds are 1 in a billion that you're in base reality, which means it's billions to 1 the other way. You're very likely to be in one of these. Now, that's one leg of the argument that I present in my book, The Simulation Hypothesis. And I think that's an important part of it, because that's where I came into this, was from the video game industry. But that's also where I think, many people stop and say, okay, that's why we're in a simulation. But I think there are other indications that the physical universe is not real. And if you think of the simulation hypothesis, it's really a collection of a few different assertions, as I see it. And the first of those assertions is that the universe consists of information and not physical matter. The second part of that is that not physical matter, that it's based on information. And then the next assertion is that somehow this information gets rendered for us in a way that we think it's real, like this chair. I mean, we think it's real, but we know now that it's 99% empty space, right? But it gets presented to us in such a way as to be a physical object. And if you go down into the molecules and the atoms, you realize, the electron, we used to think of it as this, kind of a planetary model where it's like a planet going around the sun, but it's really more of an electron cloud. Bottom line is, even that's like 99% empty space inside the atom. And if you keep going at the base level, we have these things called particles, whether it's subatomic particles. But what are particles? And I think this almost gets us into a philosophical discussion in terms of what is a particle. And there was a scientist named John Wheeler, who's one of my favorite scientists of the 20th century. He was at Princeton. His office was across the hall from Einstein. He worked with Niels Bohr and the other founders of quantum mechanics. And he came up with a phrase where he said, at the bottom level, the only thing he could find to distinguish one particle from another was a series of properties. And those properties were all answers to yes-no questions. And so what is an answer to a yes-no question? It's yes or no. It's a 0 or a 1. It's a bit of information. So he came up with this phrase, it from bit. And what he's trying to say was, anything we think of as physical is actually based on bits of information at the bottom level. And I think that's relevant because that's a key underlying assertion of the simulation hypothesis, that the whole world is based on information. And physics now is evolving to the point where we're not just talking about conservation of energy, conservation of momentum. We're talking about conservation of information. So there's a whole branch of physics now dedicated to digital physics, if you will. And so I think the reasons why I'm more and more confident about this, that we live in some kind of a simulated reality. Now, I'm not saying that our reality uses, a Pentium chip, or it's, a computer that we would recognize. It's probably a much more complex computing system than even we understand today, something akin to a quantum computer. But the findings within the quantum physics world also convince me that we are probably not in a physical reality, but we are in an information-based reality, which then leads me to the simulation hypothesis.
Yeah, I guess I'm a little surprised that you're not more all in. I guess I feel like you're trying to keep an open mind, of course, as to this being like just a genuine reality. But I mean, 2/3, or even if it's 75%, based on all of the evidence and all your studies, like I feel like I was expecting you to come in here and say, yeah, I'm 100% sure. I believe we're in a simulation, or I'm 99% sure. But you're leaving some room to be open.
Well, yeah, because I think one, we are attempting to understand the physical world based upon our cognitive state at the moment, individually and as a society. And this is what happened in ancient times as well. People tried to understand what was going on with the universe, and Aristotle came up with the spheres as a way to try to explain things. And so science is often a process of trying to explain what's going on in the world around us, but we often use analogies and metaphors to try to understand it. And so I think you can think of the simulation hypothesis as a metaphor, a philosophical idea, a metaphysical idea, or you can think of it as physically, literally a simulation that's based on information. And so different people fall in different places on that axis. I'm 100% sure that reality is not what we think it is. And so we
don't have it all figured out.
Yeah. And so the last assertion, in addition to saying it gets rendered for us, and I think that's where people have disagreements on how does that information get rendered for us, but that the universe is a kind of hoax. And for me, I think I'm pretty sure like that's 99% there. Given my background as a computer scientist, I'm trying to understand that idea of a hoax. And the closest thing that I can come up with that actually makes sense based upon our knowledge is that the world is some kind of computation that is happening on an ongoing basis. Now, the other reason why I leave it open is actually an important distinction in simulation theory. And not many people talk about this, but I believe it's an important one because it provides the bridge between consciousness and simulation, and the simulation hypothesis. Some people say, oh, simulation hypothesis is just for atheists and it's just a materialist view of the world. But there's two different versions of simulation theory, or flavors, if you will. I like to call this the NPC versus the RPG versions of simulation theory. And so NPC stands for non-playable character. And NPCs in a video game are, actually the term originally comes from tabletop games like Dungeons and Dragons back in the 70s. What would happen was that each of the players, I don't know if you've ever played
Dungeons and Dragons?
Dungeons and Dragons or a similar role.
I was big into World of Warcraft. That was that one for me was a big.
And that those are all based on the original ideas from Dungeons and Dragons, which happened before there were really computerized video games with graphics like World of Warcraft. But the idea was you would choose a character, and then there would be a dungeon master, and you would tell the dungeon master what your character does, and then the dungeon master would roll some dice and would tell you what happens. And so there were many characters in the world that were not being played by anybody. Like there's an orc or a bartender, or a tradesman who's selling swords at the armory or whatever the case is. And so those characters would be played by the dungeon master. And then as video games evolved, role-playing games evolved into computer role-playing games, and then MMORPGs, massively multiplayer online role-playing games like World of Warcraft. The computer took care of all of those NPCs. So they were basically code. They were basically AI. And so in the NPC flavor of the simulation hypothesis, we are all just running on this computer system. We are all like LLMs, like ChatGPT, and we are all AI. Now, in the past, there were dumb NPCs. So most of the NPCs in these games were not very sophisticated. You could maybe ask them a question or two, or you fought them and that's it. Today, we have smart NPCs where you can actually have a whole conversation with them. And those are just beginning to be rolled out in video games, and they're based on large language models, LLMs, like ChatGPT or Anthropic's Claude or Google's Engine, all of these different engines. Now, at the opposite end of the spectrum, we have the RPG version, which is when the characters in the video game are played by somebody outside the game. Right? And that is closer to you playing your avatar in World of Warcraft. It's also closer to the Matrix, right? So if you remember in the Matrix, Neo, Morpheus, Trinity, they all existed outside of the simulation. And then they had their character, their avatar, which comes from a Sanskrit word. There's an interesting story about how they chose that, inside. And so there's a player and an avatar or a character inside the game. And so those are two different flavors. They're not necessarily mutually exclusive. So when Elon Musk and other folks like Nick Bostrom, who wrote an article called Are You Living in a Computer Simulation all the way back in 2003, he originally came up with this argument that if someone could create AI characters, they would create lots of simulated worlds with lots of simulated characters. And maybe you're one of these AI characters. That was his general argument statistically, which Elon Musk was relying on. But you can have both NPCs and player characters inside a video game. So it's more of a continuum if you think about it. Like there's 100% NPCs or 100% players with characters, and there's something in the middle. And so, I leave room open for different versions of this. Personally, I like the RPG version because it's closer to being in a video game because we are outside the video game. It also gets into the religious side, which we can talk about, and this idea that there is a soul and a body, and the soul exists outside the physical world.
The spirituality as opposed to religion, I guess.
Yeah,
right?
More of the spiritual ideas behind the religion. Yeah, because religion tends to be the formalization of these into a set of rituals
and beliefs
and belief systems. But usually all religions are started by mystics generally who experience something. I like to say they peeked out of the simulation. They saw something. They came back and they tried to explain it. Now, imagine trying to explain something like a computer simulation or a holographic universe 2,000 years ago. Right. You really wouldn't be able to, right? And so you had to use metaphors. And so I think that distinction leaves open different levels of possibilities. And that's why, I say I think we're more likely in a simulation than not, but my percentage keeps going up. If you had asked me this 5 years ago, I would have said 50%. Now I'm at 70%. And over time, I'll probably be closer and closer. But I do think that the whole universe is not what we think it is. Like that, I'm even more sure of.
Agreed. Yeah, good. Let's get into some of the direct evidence that we have. And you mentioned the chair, and you talked about how the chair was 99.999% empty space. And so, like, if you go down and you look at things at that level, at the atomic level or the subatomic level, and you mentioned that electrons are now viewed as a what did you say?
Cloud,
like a cloud.
Yeah, or probability distribution.
Right. So let's double click on that maybe and get into some of like and maybe from there, into like the quantum world and how things are just information, I guess, is kind of your point about this, right? I mean, like the stool, the table, the chair, the shoes, even the human body itself is made up of atoms, and so those atoms are made up primarily of empty space, and it's very it's not quite what it seems, I think, is kind of what you're saying. So can you double click on that maybe and maybe just educate people about why that's such a big clue for simulation?
Yeah, absolutely. So first of all, even the idea that we consist of discrete particles in and of itself is a little bit odd because, physicists have been trying to describe the world mathematically So physicists have been trying to describe the world mathematically for years, but mathematics is continuous. And so, the first big piece of evidence is the world quantized? And that is where the name of quantum physics comes from. It comes from the idea that things are not continuous, but that there are quanta or discrete packets of energy, of light. And that's what Max Planck found way back when he first sort of defined this idea of quantum physics, and Einstein as well. And that to me shows that we are more likely to be in a universe that has a pixel, because in a computer game, the minimum distance is the pixel, and you can't really do anything less than that pixel inside that world. Now you can mathematically say pixel divided by 2, right? But that's not real in that simulated world, because you can't measure anything less than the pixel. You can't draw anything less than the pixel. And so my question was, is the world pixelated? And it turns out it is. We do have a minimum distance, which is called the Planck length, which is based on Max Planck. And beyond that, there's no way to measure anything.
And what is that? What is the Planck length?
It's like, I forget the number, like 10 to the minus 36. Maybe we can have Ryan look up the exact number, but it's a very small number. Here we go, 10 to the minus 35. Yeah, right. Any shorter makes no physical sense.
Why? Why is that?
Well, there's different ways that physicists have looked into this. And again, I don't claim to be a physicist, but to me, what they're saying is we can't measure anything less than that, which means it is a minimum pixel size from my perspective. And so you can't say I'm going to look at something that's half a Planck length.
But where does it break down? Like, does it break down because of the instruments that we're using, or does it break down because of because of reality itself?
Well, my initial thought was, maybe it's just an instrument issue, but it's not. It's reality itself. There's something about the quantum field at that level that you just can't measure anything less than that. So anything less than that becomes meaningless from a physical perspective. Again, you can say Planck length divided by 10, and mathematically you can do it, but you can't actually define that. So it becomes pretty much the minimum, the minimum distance that we can do anything in the physical world.
So if we go down to like that level and we're looking at atoms, and then what are we seeing? Like if we go back down to we're at the subatomic level at that point, right? So what is the matter? What does it look like?
Well, as you go down, right, we have all of these different atomic particles like protons and neutrons, and then you go down and you have quarks, and you get down even smaller, and you can see the radius, right, of each of these getting smaller and smaller as you go down. And so there's no actual particle that's the Planck length, because I think this idea of what is a particle is a bit of a misnomer. Right? So Wheeler, who I mentioned, came up with this phrase, it from bit. He said in his lifetime, physics went through 3 different phases. At the beginning, they thought everything was a physical particle. And then later, he said they thought everything was a field, like an electromagnetic field. And then he came to this conclusion at the end of his life that what we think of as a particle is actually bits of information. And so if you think of in a video screen, like suppose we were inside a video game, and my assertion is that we probably are, but let's assume we were inside the kind of video game that we can make now. And if you were in there's some memes out there where you have Mario and the princess saying, hey, we're in a simulation or something, right? And they were trying to figure out what was the minimum length. All they would see is some kind of electromagnetic radiation, right? Because in fact, what we think of as pixels, is when they get rendered, they're just electromagnetic radiation that is based on some properties that gives it the colors of the pixel, right? So if you look at how a screen is displayed, there's some amount of memory that has like the RGB values for each of those pixels. And it's that information that's important. So if you change that information, the thing that's on the screen changes. So I think that's one big clue that we are in a discrete, pixelated world. The second aspect of it is the speed of light itself, which is at a constant, and nobody really knows, why is this so constant? And what it shows is that, in fact, light plays some kind of fundamental role in the universe itself. And if you think of a video game, and you think of just what I was saying earlier, if you think of being inside, Mario Brothers or World of Warcraft or Fortnite, what you're really looking at is electromagnetic radiation that is meant to look like something else based on the information. It gets rendered in such a way. And the maximum, speed is the speed of light, because everything is built on being able to render that information. So that's a second clue, I think, that indicates that we may be living in a world that is made of light and gets rendered into what looks like a real world. But for me, the thing that really clinched it.
So the speed of light kind of being the maximum. So are you saying that it's basically like the max parameter that's set within the system, and that nothing can move faster than that, and that's the upper limit on the rate of speed that anything within the simulation can move, I guess, right? And then why would there be a max?
Yeah, well, that's the question. Why would there be a max speed, and why would it be specifically tied to the speed of electromagnetic radiation? And again, if we were in a computer simulation, that would make more sense, because a simulation is rendered based on electromagnetic radiation. That is how it's done. And so, like when I was at MIT, our professors would always tell us that what science is it's creating models of the physical world. And if one model doesn't quite make sense, you try to find a model in which what you observe actually does make sense. And so for me, if the speed of light is it's like a constant that's fixed in the universe, that means somehow the whole universe, is built out of that element, if you will. And that's very similar to how we render, simulated worlds within computers. And that's how we render World of Warcraft. That's how we render Fortnite on our phones. It's all based on that idea of electromagnetic radiation. So far, I think those are just clues. But to me, it was the quantum mechanics and quantum indeterminacy that really convinced me that the weirdness of quantum physics actually is telling us that we're in a bit of a simulation.
Right. So the speed of light basically, in video games, it helps the rendering and kind of like the physical load of the program, and it could be a similar thing, I guess.
And it's limited if you're sending information from one place to the next. Let's suppose you and I are both in a video game together. The fastest we can communicate, our two computers can communicate with each other, is the speed of light. Now, that doesn't mean there aren't ways around being able to go from one place to another. That's a whole different discussion around wormholes and teleporting and stuff. But just in terms of the physical rules of the universe, that's kind of the fastest processing speed. And this actually gets us into another interesting area, which is time dilation. And is there a minimum quantized time as well?
Before we get into time, can I ask you again to just double click on like the chair is information, and it's not really matter, and it's not really there, and it's like you mentioned that there's bits, and so zeros and ones, I guess, right?
Yeah.
Like, can you explain again before we move on to time, kind of how that works?
Yeah. So the minimum unit of information is bits, because there's 0 or 1. Are the two possible values of bits, at least in classical computing. Same is true in quantum computing, but we can talk about that, because that's a whole fascinating area that ties into the quantum mechanics idea. But basically, when we render something on screen in a video game, what we do is we have a description of that object, and that description is more of a, let's say, non-physical description of information. So it consists of bits of information. And the bits tell you how to arrange the object, right? So, like if this was to be rendered in a video game, we would have some bits for my chair, some bits for your chair. We would have some bits for, this little area in between, et cetera. And so each of these objects has some information that distinguishes it from other objects. And so within video games, we use 3D models as a way to describe that information. And we use it to describe, now, on our video games, it's just we're describing the colors and the shape, right? But similarly, we have 3D printers. And so what do 3D printers do? They, just like a regular printer on a 2D screen, would put the pixels of an A together or a B or a C, they would be able to print a physical object like, say, this, this cup here, and it would arrange it in 3 dimensions. So there has to be some level of information that's telling all these atoms or all these bits of particles where to go and what distinguishes them from the one next to them, right? So all of that can be thought of as information in the world itself. And that's how physicists are starting to think about the physical universe, is how much information does it take to actually keep track of all of this stuff. And so that's where I think, we get into this issue that the electrons and the atoms are arranging themselves based on some set of rules. And we don't necessarily know all the rules. We think we do. We're trying to figure out the rules. But in the end, the way that they end up placing themselves is based on the information about the shape of the world and the dimensionality of the world. And so that's where, the bits come into play. Now, if you go really down to the quantum level, what we're talking about are things like spin, quantum spin, and direction and mass of these particles, right? Each of these are like properties of the particle. And where Wheeler came out to was it's those things that distinguish one particle from another. You may have heard the news a few years ago where they said that China succeeded in teleportation of a particle. And they teleported the particle from, I guess, the level of Earth to a satellite. Now, they didn't really teleport the particle. What they actually did was they teleported the quantum state of that particle, which, they were able to get, let's say, the spin, the direction, the momentum of that particle, whatever the properties were. And then they were able to have this other particle that was able to duplicate those properties.
So like entanglement?
It's like entanglement, yeah. Although entanglement tends to say, they're slightly opposite properties. But yeah, it's like entanglement, which is saying that these two are related to each other in some way. But the point that I was trying to make, we can talk more about entanglement too, was that they were able to teleport the quantum state of the particle. And for all practical purposes, that's almost like teleporting the particle itself, which is basically saying that what makes this particle unique is its quantum state. And if we can duplicate that over there, it's just like teleporting it, which gets back to this idea that a particle is just information. And that information, is the basis for all of reality. And the basic unit of information is bits of information in information science. And I mean, there's a whole field around information entropy now, which is like, you've probably heard of the laws of thermodynamics, and entropy says that we will have more disorder in the universe over time. There's also this idea of information entropy, where any series of information or series of bits has more entropy if it's unpredictable what's going to be in that string of bits. And so that defines the amount of information. And this is actually from a guy named Claude Shannon, who was an MIT professor, and it's sort of the basis for information science today, and it's what we use for teleporting or transporting information over the internet. So all digital packets, all digital information that's transferred over the internet today is based on this idea of how do you transfer that information from one place to another. You know, in the same way that if I were to watch The Matrix on my phone, okay, I'm not watching the physical reel of The Matrix that was shown in 1999 at a movie theater, but the information is the same, theoretically, right? Sure. So the bits are the same. So that's a good way, I think, for people to think about it.
Okay. Okay. Yeah. Sticking with quantum maybe for a little while longer, I guess quantum entanglement. I want to ask you about the double slit experiment as well, but how does quantum entanglement fit into the simulation hypothesis?
Well, so I think both of these are two big mysteries in quantum mechanics. The double slit experiment, which defines the observer effect, and what's called quantum indeterminacy, and then there's quantum entanglement. And I think one of the key aspects underlying, why I think both of these actually are clues that we might be in a simulation is that they don't really make sense in a physical universe, right? If you have a physical universe consisting of particles, then it doesn't make any sense that these particles can communicate with each other over this long period of time. Now, when I looked at that as a computer scientist, and I said, well, all that means is that there must be another place in memory that is keeping track of both of those particles. So on a screen, if you watch Game of Thrones, let's go back to Game of Thrones first. Let's go to Game of Thrones for a second. If you watch one of the scenes of winter, most of those pixels are just white. So you can actually optimize the size of the file because a lot of these particles have the same values. And so I began to ask myself this question, like as a computer scientist, we like to optimize things because we have limited resources. Physicists love big numbers like infinity because they can just kind of hand wave and say, oh, that's all infinite. But, the progress in computer science has all been about, one, better hardware, and two, how do we optimize the way we do things? And we compress videos. The reason I can watch Game of Thrones on my phone, even though that same file back in the 90s, the digital file would have been way too big to send, over a wireless system, is because we compress that information. And how do you compress information? Well, you look for bits or pixels that are similar, and then you use that to reduce, the amount of things that you need to keep track of. So to me, quantum entanglement fits simulation theory from one perspective, which is that these two particles must share an information state. And that information state is usually stored in memory in a computer system. And you can have an area of memory that says, okay, it's red, or it's spinning left or right. And then the two pixels on the screen can actually reference that same piece of memory, that same piece of information. So I find it, first of all, baffling, which I think, most physicists do. But secondly, if we think of it as an optimization technique, then it starts to make a little more sense. We can say, oh, that's why we might need to have particles that are entangled in the universe, because it reduces the overall amount of processing that needs to be done for that system. In a sense, it compresses the universe in a way so that you don't need to keep track of all of these particles independently because there are always particles that are entangled. So that's one way to think about it.
So would one of the particles that's entangled be within like the memory of this quantum computer, and one is projected into the physical simulated world?
Well, I would say they're both projected into the physical simulated world, but they're both based on the same location in memory in the quantum computer, let's say. So that piece of memory, like if you think of how we write computer games, or even if you just think of a screen, if it's all based on, or even if you think of like a JPEG file or any kind of file, you've got the information of what needs to be, at each location somewhere. and that gets compressed down. And so that's one way that quantum entanglement would fit into this idea, is that they are both accessing the same memory while they are entangled. It's kind of like they're compressed, if you will. And that's how we compress information. So for example, if we have a string of bits, let's say we have 64 bits, or it could be 64,000, doesn't matter. We have a bunch of bits of information, and they're all ones and zeros. But if we know they're all ones, okay, then we don't need to keep track of all of the bits separately. We just need to know how many there are. And now we've compressed that 64,000, down to the number 64,000, but we don't need 64,000 bits to have that. Or if you think of it at a smaller level, if there's 5 in a row, you just need to keep track of the number 5. And so you might have, this is called run length encoding, where you have 1, 1, 1, 1, and then you have 0, 0, 0, and then you have 1, 1, 1, 1. And again, that could be a lot of information, but if there's 5 ones in a row, you can kind of compress that. In fact, here you go, run length encoding. You can say there's 3 A's, there's a B, and there's 4 C's, right? And so you can see that's less information than the original. Now expand that to a really big number, like 64 million bits, right? Now you can really compress it down, and now I can watch Game of Thrones on my phone because I've compressed it, and then it gets decompressed as necessary.
Yeah, makes sense. Okay. Yeah, cool. Yeah, there's so much evidence. There's so many little clues and so many little hints that this could be reality. It's just fascinating. I think we need to. For this episode, I just wanted to kind of plow through a lot of that evidence, and just have you kind of explain why this may or may not, why this evidence is legitimate evidence or why it's not legitimate evidence. But there's a lot within the quantum world, and so. What about this double slit experiment? Like, first off, just real quickly, I think most people have watched the show, they understand what it is, but maybe just a quick reminder of what that is, and then why that could be evidence for the simulation hypothesis.
Yeah, and so for me, this is one of the most interesting potential areas of evidence for being inside a simulation. In fact, this was the one that convinced me that we are more likely to be in a simulation than not from a pure science point of view. And the double slit experiment basically says that if you have a particle, say a photon of light, and you have 2 slits and you have a screen on the opposite side, in order for it to be thought of as a single particle, it has to go through one slit or the other slit. And if it was a wave, then it would basically create an interference pattern. It would almost look like it's going through both slits at the same time. And so I find the best way to explain this is not so much with the double slit experiment itself, but with this idea of Schrodinger's cat. Okay. And so Schrodinger's cat was a thought experiment where Erwin Schrödinger, one of the founders of quantum physics, came up with this idea that inside a box there's a cat, and the cat has some poison next to it, and there's some radioactive process that has a 50% chance of unleashing the poison and 50% chance of not unleashing the poison.
So this is that thing where all particles exist in all states simultaneously.
Exactly.
Guess, right? Yeah.
Right. So you can think of the cat as having 2 possible states, which is that it's alive or it's dead. Now, common sense tells us after an hour, let's say there's a 50% chance that the cat is alive or 50% chance the cat is dead. Common sense tells us, okay, the cat is alive or dead. We don't know. We just haven't looked in the box, right? I mean, yes, there's cruelty to cats, right? But this is a thought experiment. But what quantum mechanics is telling us is that the cat is in both of those states. It's actually both alive and dead until an observation or a measurement is done on that system, which is the equivalent of saying until you look in the box. Somebody looks in the box. Then the cat goes into only one of those states. It's only going to be either alive or dead when we look at it, right?
So it's like light. Light is both a particle and a wave until you look at it, and it's the point at which it's observed that determines which one it is. The cat,
yes.
The cat is in both states. Either it's both alive and dead. It's not either alive or dead. It's both alive and dead until it's observed.
That's right.
Yeah.
And that state or of being in all of those states is called a state of superposition, because there's multiple positions.
Okay.
And it's the analogous to the two slits, which is, did it go through slit A or B? And the answer is it went through both until somebody measures it on the on the other side. And then once a particle is measured, then it looks like it just went through one of those.
And this is proven over and over again.
This has been proven again and again. And this is why, Richard Feynman, who's Nobel Prize winning physicist, says no one understands quantum mechanics, because that doesn't make any sense from a common sense point of view, right? The chair is here or it's not here. It can't be both, right? And Niels Bohr said that anyone who's not shocked by the quantum theory hasn't really understood it, because it's so weird from a classical perspective and from our way of thinking about the universe. And so this idea that the universe basically goes into one state when it's observed, there have been what are called interpretations of quantum theory to try to explain that. And the two most popular interpretations are the Copenhagen interpretation and the multiverse explanation. And we can talk about the multiverse later, but let's focus on the Copenhagen interpretation. And the idea there is that you have a set of probabilities, and what happens is that those probabilities get collapsed down to just one possibility when it gets observed. And no one knows how that happens. In fact, some people don't like the Copenhagen interpretation because there's no math to say how that happens. It introduces another idea, which is that there might have to be a conscious observer. And when that observer is there, then the universe takes on a specific set of values or positions. And yeah, there are good graphics where before you can think of the probability wave, and after it ends up being just one of those. So it collapses to 100% likely that that is what's happening at that point in time. Now, to me, that doesn't make any sense if we live in a material physical universe, because what it's saying essentially is that the world is on demand in a sense, right? That it gets, now as a video game designer though, that does make sense to me, because if you're in World of Warcraft, guess what? Your computer is not rendering the entire World of Warcraft. Or if you're in Fortnite, or you're in EVE Online, which is like a space game, or any of these games, or there was a game called No Man's Sky.
It's only rendering where the players are.
It's only rendering where the players are and where your avatar is. So in a sense, you are looking at a screen and you are rendering the piece of the world that is being observed. And if somebody else is observing it, then they're rendering it as well. And so it becomes what I like to say cached, what we say in computer science, when you cache those values so that other people can see those values as well. But basically the rule of thumb in video games, the reason we can do World of Warcraft today, like when I first learned computer programming back in the 80s, and I had my little Apple II computer, and we were writing basic code, and we were trying to put the pixels on the screen for like a tic-tac-toe or something. And there was just no way to keep track of all the pixels in a fully three-dimensional virtual world. And since then, what has happened is we've gotten these optimization techniques, right? And the optimization techniques say render only that which is being observed. And to me, that ties into this idea of the classical physical universe versus the quantum universe, where in the quantum universe, it's basically saying you only need to render that which is being observed at that point in time. And until that happens, it's just information, and it's a set of probabilities wherever those probabilities are stored. And that's what we do in video games. We have a set of probabilities, and it's only when your player is there that we actually render that for you. So from that perspective, getting back to this question of why would a physical universe work that way? We don't know. It's baffling. But if we were to say, well, this is a world where we are players and we are observing this universe, Wheeler said, this idea in science, and this is another reason why he's one of my favorite physicists, that what quantum mechanics did was it broke this idea that you could have a subject and an object, and that the scientist could just observe the experiment, because the scientist observing the experiment is a key part of the experiment. And to me, that also resembles players of a video game who are sitting there and the universe is getting rendered for them. So that was the thing that really convinced me. So if you go back to the games we made in the 80s, what we did was we laid out all the pixels. We said, this is red, this is blue. We had artists, right? And the artist would like draw every single screen. Like there's an image, there's a game called King's Quest.
Oh yeah, I played that when I was a kid.
Oh yeah, yeah.
Mm-hmm.
I thought that was really cool.
One of my first games, yeah.
Yeah, and there's a picture, maybe Ryan can try to find it, of King's Quest. It shows you all of the different possible bitmaps, if you will, of the entire King's Quest universe. And so like if you do a search on King's Quest and like screens, it's like all the possible screens. And it turns out each of those screens was already rendered as a set of pixels. And we stored it as a set of, say, JPEG. They didn't even have JPEGs back then. But yeah, if you look at one of those up there at the top, you can see, let's see if you can find, yeah, you can see sometimes there's these squares that are next to each other, right? So you can see that the world is a continuous set of pixels. Like if we look at any of the ones like in the middle there, for example, on the right. Yeah, or even that one where there's the water and then there's, say, the island, right? But the idea is that each of those screens exists physically and then the character just moves through it.
Sure.
Right? So that's a classical view of the universe. But if you look at something like Doom, which was one of the first first-person shooter games that really, that got really popular. In fact, it got so popular that networks were coming down in colleges in the 90s when it came out because people were playing each other. But within Doom, they only rendered the part that you could see from the first person's shooter's point of view. And so that was an optimization technique, right? And so my point is, if we think of the universe as information and computation, then suddenly something that is completely unexplainable at least starts to make more sense. It becomes an optimization technique for the universe.
So there's all this evidence for simulation theory being real. There's all of this. There's all of these mysteries that we can't explain today, like the double slit experiment, like a lot of the stuff we've been talking about. Is there evidence to suggest that the simulation hypothesis is not real? Because all I'm hearing is evidence that it is real, and it solves a lot of the mysteries that we have, and we're going to talk about more of them and more of the evidence. But is there evidence that we found yet that says simulation hypothesis is not real?
Well, I don't know that there's so much evidence as there are arguments, right? And arguments come in different forms, and we can go back to Bishop Berkeley, who came up with this idea of idealism, which is that the whole world is some kind of mental projection. And, this friend of his, Dr. Johnson, said, I refute that. And Berkeley says, how do you refute that? He goes, I refute it thus. And he kicks the stone. And he goes, see, it's real. Right? And so the arguments that are against it, I'm saying that argument kind of flippantly, but if you were inside a video game and you tried to kick a rock, your foot wouldn't necessarily go through the rock, right? So it would seem real. So there's arguments like that. Now there's more sophisticated arguments.
That's what I'm looking for.
Yeah, that have come out more recently. I just wanted to point that out to say that there are different there's different classes of arguments. And so first of all, we haven't proven that we're in a simulation, and we haven't been able to prove that we aren't in a simulation. So we're really looking at evidence and arguments and doing an interpretation of those. There's a guy named David Chalmers, who's a philosopher, who came up with this phrase, the hard problem of consciousness. And he says, if we're in a simulation that's perfect, then there would be no way to detect it, right? So we wouldn't be able to prove it if it really is perfect. But as we know, most computer programs have glitches, so there may be ways to look for things. So there's a class of arguments that have come out recently that basically say that there's too much information in the universe. No computer could keep track of it. And in fact, somebody told me this the other day. They said they asked Bill Gates, and Bill Gates said, well, it would take a computer bigger than the universe itself to keep track of all the information in the universe.
Yeah, but all we have to do is keep track of the information on the planet Earth and be able to render any information whenever we send out probes or satellites or whatever. We don't need the whole universe.
Exactly.
Yeah.
Because, like I said earlier, physicists love infinity and big numbers, and computer scientists always think about how do you optimize, right? And so it turns out you don't need to keep track of everything. You only need to keep track of that which is being rendered at that point in time. Now, there was an argument, for example, by, I forget which astronomer it was, but it was some astronomer in the New York Times back in the 20th century, mid-20th century, and he wrote a big article saying there's no way we will ever be able to go to the moon. So why? Well, if you calculate the amount of... Well, right. Well, yeah. So that's another discussion. But he was saying it from the perspective of if you calculate the amount of fuel that's necessary, it would be heavier than the rocket you need to launch it from. Therefore, it's not possible. And so that is the class of arguments that are being offered today.
So there's no good arguments.
I don't think there's any good arguments. I mean, it's not that they're bad arguments. They just make assumptions that are different than the assumptions that someone coming at it from a computer science point of view would make, which is, again, if you use that logic, there's no way you would ever be able to, wirelessly watch Game of Thrones. Why can you? Because of optimization and compression. And so as long as the universe isn't optimized, fine. But even if you did need a computer as big as the universe, okay, let's assume the argument is right. I'm not saying that we're running on, a Windows, 10 or 11 computer. The computation that runs our universe is most likely a quantum computer. And it turns out quantum computers can solve tasks that would require more particles than the entire universe has in them. And we can talk about that now, or we can talk about it later, but I think it's a fascinating area. So quantum computing can theoretically run a process which would take a normal computer thousands of years, or literally millions of years. And breaking encryption, for example, if we look at the total number of particles in the universe, the estimate, I don't know what the latest estimate is, but something like 10 to the 80 or something like that, right? There are quantum problems which require solving and looking at more than 10 to the 80 possibilities, which quantum computing can theoretically solve quickly. And nobody knows how that's done exactly. And the way it works is because you put the quantum bits into superposition. And so now we're going to talk about qubits for a second.
Okay.
But before we get into the qubits, quantum computers are good at solving problems that grow exponentially. And I think the best way to explain, how big these numbers are is to use the old story of the king and the chess board from India. Though there was a king who loved to play chess, and everybody had played against him, and nobody wanted to play with him anymore because he was so good. And he went to this wise man. He said, "Will you play chess with me?" And the wise man's like, "Not really." He goes, "Look, I'll give you anything you want if you beat me in chess." And the wise man says, "Okay, if I win, you should give me 1 grain of rice for the first square in the chessboard, and then double that on the next square, 2 grains of rice, and double that, 4, 8.
There's not enough rice 15. In the world.
Yeah, the rice would have taken up more land than India, than all of India, right? 2 to the 64. It's 18 quintillion grains of rice. And that's what we mean when we say these problems grow exponentially. They get really big because it's 2 to the n or 10 to the n. And so there are encryption problems which would require looking at more possibilities than 10 to the 80, which is all the particles we have in the universe. And yet somehow quantum computing can solve it. And the way that it does that, theoretically, we're still building quantum computers, but there has been indication that it can solve those problems, is instead of every bit having just the value of 1 or 0, every bit goes into superposition. So that means it has both values, 0 and 1. And so if you have 2 bits, If you have 1 bit, that means you're exploring 2 possibilities at the same time. If you have 2 bits, you're exploring 4. And if you have 3 bits, you're exploring 8 and then 16. Like each time you're doubling the number. I mentioned this game No Man's Sky earlier, which had 18 quintillion worlds. And turns out that is 2 to the 64 power. And so what quantum computing does is it puts the bits in superposition, and then it tries to find the right answer out of all the possibilities. And then you observe and measure those bits, and then it gives you the answer. And nobody really knows exactly how it works, but part of the explanation that's been proposed is that it is, in fact, exploring all the multiverse of possibilities. But my point there, we haven't gotten into the multiverse too much, but my point there is that quantum computing can do things at much larger scales than we think. And so the arguments don't necessarily hold up.
They don't work. Yeah. And we kind of started off with this saying that of course it's possible. You know, of course that some advanced civilization that's had 2 billion years to grow and advance scientifically could have developed a computer to make this possible. I think we got to people have got to get past that and understand that it's a possibility. And from there, then you can decide whether or not you believe it or not. But there's a lot of evidence that supports it. And there's not really, from what I'm hearing and from what I understand, much meaningful evidence that would say that it's not possible, you know?
Yeah, I mean, there was a German scientist who put out a video, Sabine Hofstadter, I think, and you know, but it basically her argument came down to, we don't know how to do this, you know, and it's like, well, just because we don't know how to do something today doesn't mean that it's not possible. It just means we don't know how to do it today, and I think quantum computing belies that.
Have you thought about the moon at all as it relates to this topic and some of the anomalies of the moon?
Yeah, I think, actually, can we take a quick break
let's do
before we get into that?
Absolutely. Yeah. All right, perfect. Well, we are back. I think we decided we're going to hold off on the moon until we get to the UFO section, so that'll fit in better there. But what about time? Why don't we dig into time a little bit more and how it relates to the hypothesis?
Yeah, so the way that I've come across it and how it relates to the simulation theory is, first, we started with space and said the physical universe is not what we think it is. And that's kind of the subject of my book, The Simulation Hypothesis. But there's also this aspect of it that says time is not what we think it is either. But before we get into the really weird stuff with time, you know, one aspect of time that's interesting is in a computer simulation, time is quantized in that there is a minimum clock speed of a processor. So if you've seen the specs for any laptop computer, they'll say it has a 7 gigahertz processor or whatever it is. Hertz just means cycles per second. So if something is 10 hertz, that means there's 10 cycles, and you can think of it as sort of 10 computer commands or instructions per second. And in a digital universe, there is a minimum amount of time as well as a minimum amount of distance. I mean, you can't really do anything at less than that minimum amount of time. So everything is a multiple of that. And an open question is, in our physical universe, is whether time is also quantized. And we've already talked about space being quantized.
The Planck unit.
The Planck length, yeah. But there's also this unit, which has been theorized, called the Planck time, which would be the minimum amount of time. Now, how that's derived is simply by measuring how long it takes the speed of light to get from, one side of the Planck length to the other side. So you can think of it as the minimum pixel, but also the minimum amount of time that can possibly go through. Now, this is more controversial than the Planck length. I mean, not in terms of definition. Definition is easy. It's, the Planck length divided by the speed of light. That's easy to write. But whether time itself is quantized. And, there's a great quote from St. Augustine. So we're going, way back now. And he said, "What then is time? If no one asks, I know. But if someone asks me, then I do not know." Right? And I think that's true of physicists too, by the way.
Yeah, right.
It's just as true for physicists as it is of mystics, which is that there's just this weirdness about time. So I think if we do find that time is quantized, that becomes another piece of evidence yet.
Well, I mean, isn't it? I mean, if space is, then doesn't time have to be, since they're completely correlated and you can measure one against the other?
You can measure one. By definition, you can define it that way. But physics hasn't actually, physicists aren't as certain of it yet, let's say. They're still stuck in the classical mathematical world where everything is continuous, right? Where you can always subdivide it to a smaller and smaller level. So quantize means there's a point at which you have to stop subdividing. You can't subdivide it.
But if this is a Planck and it takes light this amount of time to go from one end to the other, then that's the minimum amount of time. If that's the minimum amount of space, then that's the minimum amount of time, right?
That's the argument. And I agree with that argument.
Yeah.
But to me, that is indicating that time is also quantized and that there is a clock speed to the universe and it has something to do with the speed of light. So I think that is interesting evidence. I'm just trying to be clear on where physicists generally agree and where they don't necessarily.
It just seems like if one is right, then the other is right.
Yeah. Well, the other is definitely something you can define based on this. They're defining each other. But has anyone been able to measure any less time than that amount of time? And we can look up what that number is. Not yet. All right. So it hasn't been proven, but I think it's pretty likely, in my opinion, that time may also have some kind of quantization behind it. But the real weirdness of time comes when we talk about the past and the future. So it seems obvious to us that we can have multiple possible futures. Let's suppose I decide to live in New York versus Los Angeles, right? Or I go to school in one place versus another. That kind of leads me down different paths. So it's pretty easy to visualize what is often referred to as the multiverse of different possibilities with each choice that you make. But what's not so easy to visualize is what if there was more than one possible past? Because we're used to thinking of the past as being fixed. Now, getting back to my favorite physicist from the 20th century, John Wheeler, he also proposed an experiment called the delayed choice double slit experiment, which was meant to measure not just whether whether light goes through one slit or the other, or whether the cat is alive or dead, but it was also meant to measure what is the history of that cat. Like, what did it do before it went in the box? Did it come in from the yard, or did it come in from the kitchen, for example? And probably the best way to explain this is to use the cosmic delayed choice experiment. And I think we can get a graphic. Yeah, so there's a graphic we can use that makes this, I think, much easier to understand. Because if you look at diagrams of the delayed choice double slit experiment, it gets really complicated. But this is actually relatively easy. So if we think of a quasar or some object like a quasar that's really far away from us, let's say it's 1 billion light years away, and the light coming from the quasar has to go to the right or to the left of some big object in the middle. And in this diagram, there's a galaxy in the middle. Could be a black hole, could be any large, gravitationally large object. And on Earth, we can have these telescopes which measure the polarization of the light, but basically we're trying to measure which way did it go around the galaxy. Did it go to the left or to the right? Now, if the galaxy is halfway between the Earth and the quasar, it's going to take 1 billion years for the light to get from the quasar to us, because it's 1 billion light years away. So simple math. And if the galaxy is half the way between us, then this decision of whether to go to the left or to the right would have generally had to have been made, like, let's say, 500 million years ago. And so that is the past, right? What was going on Earth 500 million years ago? I mean, we're even, into the age of the dinosaurs, or maybe even earlier at that point, right? And what this experiment is telling us is that it's only when the telescopes measure the light, the polarization here, that it makes the decision of whether to go to the left or to the right of the galaxy, which means that it's telling us that there are two possible pasts from 1 billion years ago, one where the light goes this way and one where the light goes that way. That's weird. It's telling us that the time of the dinosaurs isn't fixed, that there are multiple possibilities. Okay, now that sounds weird because it's almost like by measurement, we're affecting the past. Again, this makes no sense in a material universe with one timeline and that's all that's going on. And so what this suggests is that there are multiple possible pasts and perhaps there are multiple timelines going on here. So time is not what we think it is.
Is it multiple possible pasts or is it that we just haven't measured it yet to know which one it is?
It is that we haven't measured it to know which one it is. But so the other interpretation of quantum mechanics was the multiverse interpretation. And that interpretation came about because some people didn't like the Copenhagen interpretation, which requires some observation or consciousness, and they didn't like that.
Yeah, the multiverse is, I think we skipped that.
Okay,
yeah.
Well, so it gets very complicated, right?
Yeah.
But the idea is that there's maybe more than one possible future. And so in this case in time, though, there was actually a quote from Schrodinger from the 1940s, and I found it. I looked, it was sort of an obscure quote because I've only seen it like referenced once or twice. And he said, "We are essentially choosing from one of multiple possible pasts." And actually, his exact words were multiple simultaneous histories. So it's not so much that we're changing the past as much as we're selecting a past. But again, that doesn't make any sense. Right? If there's only one solid past that's happened, does it mean that in the future somebody else could select from a different branch? Okay, so now we get into really complicated aspects of time. But in a simulated universe and in a video game, you know, we basically make up the past when it's needed. So getting back to this idea of an on-demand universe, if you've ever played a game like Farmville, you know, which was like a social game on Facebook, or even in Minecraft, they have similar mechanics. In fact, some of the games we built had similar mechanics. And the idea is you're going to grow some crops, right? So you plant some crops and then you go away and you got to come back and check your phone, say the next day or, you know, in an hour. And it'll say time inside the game has passed. Let's say a day has passed inside the game. So the crops have grown. Let's say you don't check it till tomorrow, then maybe more time has passed. Now, what happens at that point, with the way these video games work, is the crops aren't growing the whole time. Like, we're not sitting there on the server saying, okay, now your crops are at 1 centimeter, now they're at 1.5 centimeters. That's too much computing power. Imagine doing that for 100 million players or something, right? What we do is when you log back in, we say, okay, let's fill in the past. Let's fill in what happened. There was a 50% chance that there were some locusts that destroyed your crops. There was this much. This is how fast your crops would have grown. There's a chance that somebody stole some of your crops or whatever. But we fill in the past for you. And that raises a really troubling question for us, which sounds like science fiction. You know, I'm a big fan of Philip K. Dick, who wrote the novels behind movies like Blade Runner, Minority Report, etc. And he introduced in his books this idea of false memory. But if the past is filled in for us, you know, that to me suggests, once again, I mean, it's not proof, but it suggests that like a computer game, we are filling in what is necessary for the current run of the simulation. And we perhaps, I mean, Philip K. Dick gave a speech all the way back in 1977 at a science fiction convention. It was in Metz, France. And he said, we are living in a computer-programmed reality. And the only clue we have to it is when some variable is changed, some alteration occurs in our reality. Now, I interviewed his wife when I was writing my book, The Simulation Hypothesis, and she said, you know, have you read that whole speech? And I had just heard that one quote, because he was one of the first to really suggest this idea. And in fact, the creators of The Matrix, the Wachowskis, were inspired by Philip K. Dick. Because his ideas get into, are we AI, are we not? Blade Runner, is this real, is this not real? In many of his works, and time. And what he was suggesting And I wrote my other book, The Simulated Multiverse, on this idea that he was suggesting that somehow there were simulators that could go back and change variables and rerun the simulation. And there might be glitches and things that are different along the way. And some people actually remember the previous run of the simulation. And so it raises this idea that are there possibly multiple runs of the simulation? And, he came to believe that his novel, The Man in the High Castle, which became an Amazon series, pretty popular series, which in that series and in the novel, it's an alternate history timeline. It's when, in that timeline, Germany and Japan won World War II, so the Axis powers, and they divided up America between them. And then, the story takes place, in New York and in San Francisco. It's a pretty interesting storyline. And then somebody in the science fiction novel, there's the Japanese guy, who's able to jump into our timeline where, the Allies won World War II. So San Francisco looks very different. Sorry, spoiler alert for those that haven't seen it, but it was in 1960, I think is when he published the novel. But he came to believe that was a real timeline that was unwound because he started to have memories of it. And I'm not saying that's necessarily, some people might explain that away in weird ways, but it provides a way to think about this idea that time isn't what we think it is. That time, if we think of all the possibilities of what could have happened, that time, as we think of it, is really just one path through the set of possibilities. And to me, that is very much like having different possible values in a video game, and you run it, and now you can run it again. You can change the variables, and you can run it again. But the fact that time is not what we think it is, to me, suggests we may be in a simulated reality, and the past is not what we think it is, and the future is not what we think it is.
Yeah, makes total sense. Good. What about consciousness? Maybe we shift gears a little bit and move into consciousness and talk about that, and like how does consciousness relate to simulation theory?
Well, so for consciousness, I think we go back to this discussion of the different flavors of simulation theory. And so for me, the NPC versus the RPG versions of simulation theory are really relevant in talking about consciousness. Because I think the general scientific view is that consciousness is just an emergent quality of the physical neurons, and that's it. Like, consciousness does not exist outside of that. But as many scientists have pointed out, it seems to be not enough of an explanation. It's an incomplete explanation for consciousness. And many other people believe that consciousness exists outside of the body, and the brain is kind of a receiver, if you will, for consciousness.
It's the computer. It's the indwelling computer.
Yeah, exactly. Yeah. And so that is closer to the RPG or the role-playing game version, in my opinion, in that consciousness exists outside of the system, not inside the system. So consciousness isn't just a matter of getting the neurons, in the right order, if you will. But in the video game, you have the player that exists outside and controls aspects of their character. Now, that might be a full control, like if you have a virtual reality suit. If you've ever seen the movie Ready Player One, for example, where he has like a full body suit and he puts on virtual reality, or in The Matrix, where he's connected through a brain-computer interface, and the player is controlling what happens. And it gets into this issue of free will versus not free will as well. Whereas if it's just code in the simulation, then it's just, like a deterministic process that runs with AI, and there's no consciousness outside of that, of that process and of the physical arrangement of the neurons.
Yeah, I think it's like if the mind is, if there's separation between true self and false self, or the mind and the spirit, the spirit that you are, as opposed to the mind that you have. If we are life itself, then then it's the mind that is interacting with the matrix. It's the mind that's processing the light that's coming through your eyes and attempting to understand the world around us. But the light and the world around us is the matrix. And so the mind is very, very deeply and intimately connected with the matrix. And I guess the question of consciousness comes about because we all, because is the consciousness that you are, the energy that you are, the spirit that you are, is that connected to the matrix, or is it a separate component of the matrix? Like, does it, these near-death experiences are so fascinating because it's because of what people see and what they experience after the spirit that they are has left the body that they have, after they've left this connection with and to the matrix. And so I guess when I'm thinking about consciousness and why I asked the question, I mean, it's again to try to find some of those glitches that we have within the matrix. So it's to try to find, and to talk about things like near-death experiences, things like out-of-body experiences, but deja vu and lucid dreaming and psychedelic states where you feel like it's more real than real. You feel like and like what you're experiencing is actually reality, as opposed to what the mind sees and interacts with, which is potentially a computer simulated reality or a simulation reality, So sleep paralysis entities, ghosts and apparitions and voices and all these things that people experience like through their consciousness. I guess my question is, how does consciousness, is it a part of, or is it separate from the matrix?
Well, so, this is the big question, right, that physicists have been debating. And even within quantum mechanics, there's this question of, is consciousness fundamental, or is the material universe fundamental and consciousness is derivative? And this is why I like to bring up the NPC versus RPG flavors, because I believe the RPG version, where there's a player and an avatar that player is connected to, actually fits a model that could produce these different types of glitches. And so the spirit is the player in this case. You are the player, but what happens is when you go into the game, you basically forget, just like I did when I was playing with virtual reality, although I only forgot for a moment, but you forget for much of your life. It's like you reset, or you raised what's called a veil of forgetfulness in many traditions. And so from my perspective, consciousness exists outside of the matrix, but it gets attached to a player within the matrix.
Right. It identifies with the body, with the mind.
With the body and the mind.
Yeah.
And to me, that is also at the heart of what many of the world's spiritual traditions have been telling us.
For sure.
And in fact, there's metaphors that are used by mystics to try to describe this process. And of course, they didn't have the same terminology or technology we had today. And there's a metaphor that's used, for example, in the Bhagavad Gita, and it says that the soul enters the body or puts on the body in the same way that the body puts on a set of clothes. Or in the case of the Hindu or Buddhist religions, you take off the clothes and then you go and you live another life like you're putting on the clothes. Now, clothes are a technology. It's a techno-scientific metaphor. And it turns out in the Western traditions, in the Judeo-Christian Islamic traditions, you have a similar metaphor. Like there's a Sufi saint and poet named Rumi who's become really popular here. And he wrote something called the Masnavi, which basically is considered like the Quran in Persian, even though it's a Sufi document. It's a mystical document. And he says that the soul puts on the body like a pair of clothes. Right? So he's using the exact same metaphor to try to describe what happens. And then in the Greek traditions, you have the soul incarnates by crossing Lethe, which is the river of forgetfulness. So again, you have a way for them to try to describe something that is very complex, but they didn't have the words for, so they used the metaphor of a river. And in the Sufi traditions, there's the 70,000 veils between spirit, ultimate reality, God, and you basically you're putting on these veils as you go. And part of what the mystics, as opposed to kind of the everyday religion, which is more about rules and things you do, the mystics are trying to take these veils of forgetfulness off, which is very similar to what the yogis talk about, which is they're trying to realize, there was a yogi who would always ask, if somebody said, I'm doing this or I'm doing that. And he said, who is I? Who is the I? And he said, keep inquiring about that I. And it's about remembering and getting over this veil of forgetfulness. Now, NDEs, near-death experiences, for me, are among the most interesting aspects of this. And I first really started paying attention to the subject back in the 90s. And now we have many thousands of stories that people have told, and they're just remarkably consistent. Right? I mean, not all of them have the exact same elements, but many of them have. And, Raymond Moody put out the different elements all the way back in 1975.
I'd say there's even millions now, that there's thousands documented and studied, but that you go around and you talk to people and that it's like, yeah, I had one. I had an out-of-body experience.
Yeah, you can basically go to any particular large gathering and you'll find somebody. I mean, I was at a conference in Alabama last year, and I was sitting at a table talking about this, and there was a woman who had one. I was talking about life reviews. And so for me, where the virtual reality part comes in is people who have had near-death experiences, or even people who've been close to death, have come to this conclusion that the world is a kind of hoax. And you may be familiar with Roger Ebert. So, he didn't have an NDE, he had a DE, he had a death experience, but his wife was with him when he died. And he said the last thing he said was, "Oh my God, it's all a hoax," meaning that everything that we thought was real was not real. And so, as I mentioned, I started paying attention to near-death experiences back in the 90s from a guy named Daniel Brinkley. And he wrote a book called Saved by the Light. And he was struck by lightning back in the 70s. And he had one of these NDEs that had all of these aspects, like going out of body, looking down on his body, going through the tunnel, seeing a being of light. And then he had this life review. And that's what really caught my attention. And that's what really got me to look for parallels between simulation theory, weird phenomena, and NDEs. And in the life review, he called it a holographic, panoramic replay of everything that had happened in his life up to that point in time. But the trick was he had to experience it from the other people's point of view. So it wasn't just like projected up there. It was he had to be that person. It was almost like he had to step into their avatar or their character and experience. And so he had been at Vietnam. He had been in the military. He had shot people. And so he said he had to feel what it was like to get shot by himself. And that was a humbling experience. But he also had to experience the ripple effects of that guy dying. So he had to see what it was like for that person's family, that he wasn't coming home, for the kids. And, this went from small things to big things. Small things where somebody smiled. You might smile at someone and it makes their day because they're having a bad day. And so, for me, as a scientist and as an engineer, I say, okay, let's take these stories at face value. And there have been enough of these stories now. It's kind of like if 1,000 people say they've been to China, the materialists will try to deny there's no China, but all these people are saying that there is a place called China. They might have slightly different variations on it, but we can assume there's some place that they went to that they're all talking about it. It's not like they're all colluding. And so I think we can conclude that the life review is a real thing.
Well, the whole process.
The whole process.
It's the same process for almost everybody that goes through these things, that they rise above their body. They're greeted by beings. 25% of the time, the beings are loved ones. They see a light. They see a tunnel. They go through the tunnel. They're greeted by a being that's all loving, all compassionate, all forgiving, non-judgmental, a being of pure light and energy. And time has changed. Time slows down. And it's like, it's the same story. If you make it far enough into the near-death experience, if you just get just a minute into it or 30 seconds into it, maybe you just rise above your body and see the beings. But if you're 8, 7, 8, 9, 10 minutes into it, you're being greeted and you're having this life review. So, I mean, this has been studied and documented, like, and you're right, unless everybody's colluding, which they're not, because they're from different parts of the world with different belief systems and different experiences. Nobody, people don't know each other. This is something that I think is a clue to the nature of reality that is essentially, it's not being ignored, but people are, well, yeah, maybe it kind of is being ignored, but in addition to that, it could be evidence for just the nature of things. And like, certainly for simulation hypothesis, how it works into that is fascinating. So, yeah, keep going. I'm sorry to interrupt, but I wanted to add that color and clarity for people who aren't familiar that there's thousands and thousands of these cases, and they're all very, very similar, and people are reporting the exact same experiences within them.
Yeah, I think that's true. And there have been a number of books now, that go through the evidence for this. And there are even shared death experiences where, two people are able to see what's going on, even though they're not in the room and they're connected. So I think there's a lot of evidence that there is something to near-death experiences. But for me, the life review was the clincher, because if you're going to replay everything, it has to be recorded somewhere. Right. And they report that they're outside of the physical world, and that the physical world is some kind of a hoax. And so a few years ago, around the same time that I was playing the VR ping pong game, I was involved in a startup in Silicon Valley. And what we would do is we would take a game like World of Warcraft, which you've played it, so you play it on a 2D screen and you're watching your character along with the other characters. And what we could do is we could go back into a recorded game of World of Warcraft, and we could go to any XYZ location, and you could put on a virtual reality headset, and it would be like you were there on the ground. Or a game like League of Legends, for example, which is, similar fantasy themed game where people are fighting each other. And it would be like you were there, so you could see what it's like to get stabbed by your character. Or Counter-Strike Global Offensive, which was a first-person shooter, a multiplayer game. It's set in like a desert-like, Iraq-like environment. And you could see what it was like to shoot yourself. And so for me, it made sense that if we take that at face value and say that we're going to replay these events, and sometimes those replays include moments that we were not present at, that all of that is being recorded. And so what we were able to do is we could go back to any XYZ location in the game, and you could view it with what's called a virtual camera, and you could replay it, and you can go to any time within. And it turns out this is a very common thing to do with video games. People record their video games sessions, and then they show them on YouTube. In fact, it's like the first or second most popular content on YouTube is actually watching a replay of a video game. I remember when one of my nephews was young, he was like 3 or 4. He said to his father, who's my brother, he said, "Oh, I want to watch Star Wars." And he goes, "Oh, you want to watch the movie Star Wars?" And he said, "No, I want to watch that man and the woman play the Star Wars game." So it was a YouTube video of a recording of a game. And it kind of reminds me a little bit of, the football team that goes back and reviews the tape. And so I began to wonder about the parallels in different spiritual traditions. And I found that the life review is not just like we can have an explanation for it if this is a virtual reality. Because in a virtual reality, the whole thing is fake, but you can go back and you can replay any part of that, and you can go anywhere within that, and it'll seem like you're absolutely there, which is exactly like the life review. Now, we don't have the ability to replay emotions while people are playing the games, but eventually we could. If we have brain-computer interfaces, we could know what's going on, and we can have a virtual camera going different places. I looked in the world's spiritual traditions, and turns out they have something similar, but they use different metaphors for it. So in the Quran and in the Bible, there's what are called recording angels. And there's like a statue in Washington, D.C. of, the recording angel writing down in the book of life. Now, some people say, well, it's just writing down the names of who gets into heaven or hell. Here's an example of a recording angel. But some people actually say, well, it's about what you did along the way. And St. Peter reviews your book of life in turning out. And in the Quran, they're actually very explicit about these recording angels. They say there's 2 angels. They even have names for them. that are sitting there writing down all your good deeds and your bad deeds. And they write them on something called the scroll of deeds. Okay, now what is that? That's a metaphor, right? And at the end, what the day of judgment is about is looking at your scroll of deeds. And in fact, there's a line in the Quran that says, on the day of reckoning, your book shall be open to you and you shall read it to see what you did along the way. Now, I tell people, okay, that was a metaphor. That didn't mean that there's like literally angels with wings sitting on your shoulders with a feather pen writing down, he got up and went to the bathroom today and he went and had breakfast. What language would they be writing in? Would they write it in Arabic? Would they write it in Chinese? Would they write it in English? And so that's a metaphor for saying that everything is being recorded. And it's a technological metaphor, right? The book is probably the most important technology we've ever developed. And so perhaps mystics and who start spiritual traditions, usually they have experiences where either something peeks through from outside the physical universe, like an angel or something, or they're doing mystical exercises, yogic exercises, fasting. They're doing these, and they start to perceive that there is more to reality than what meets the eye. It's usually one of those two that leads to the insight, which then eventually becomes a religion. And so they have to go and explain those insights to people. And so they have to use the language of the time. And so, this idea of angels doesn't necessarily mean there's like these angels. They're a function. Recording angel is a function, like a process that runs on a computer that records everything that you do along the way. And in Islam, for example, they have this idea that the difference between humans and angels is that humans have free will and angels don't. And, well, let's go back to the simulation hypothesis. Well, what would that be? It's like NPCs that don't have free will or functions that just run along the way. And then humans who are players with a spirit that can actually make a choice of where they want to go in the game. And then it turns out other traditions have this. In the Hindu traditions, they have Chitragupta, who sits next to Yama, the god of death. And his role is the record keeper or the accountant. And he's writing down all your good deeds and your bad deeds. And it determines whether you go to the heaven, hell, or where your next life will be. And I'm like, well, that's the same metaphor, right? Again, it doesn't mean there's one guy that's sitting there, or St. Peter is one guy who just stands there and decides for everybody. These are functions that are performed by some greater reality. And the key point is that they can go back and zoom into any part of your life, which was some kind of a hoax. And in the Quran, it even says...
I'm sorry, but yeah. The hoax, I think, is potentially that... that we are our minds. It's the being locked into this matrix via our minds. And you talk about free will, and you talked about feeling your emotions a little bit earlier. Free will is almost like if you believe that you're your mind and you mistake that for your true self, which is spiritual in nature. I think we get a glimpse of that through these near-death experiences and these out-of-body experiences. But when you mistake yourself for your mind, there really is no free will, because your mind is just reacting to the world around you. There's no consciousness there that's making any decisions. It's the tool. Just like your lungs are breathing air and your digestive system digests food and your heart pumps your blood, your mind is thinking, and your mind is processing information and it's thinking. And so the ultimate illusion, the hoax, has to be that I thought I was my mind this entire time, and it's like the guy who is near death. Oh my God, it's a giant hoax. I feel like that's a part of this, and that's what kind of gets into the spirituality topic and the consciousness topic. And I've had some deep, I'd say, revelations or awakenings about the emotions recently in the past year, and I haven't shared this on a podcast yet, but the emotions. It struck me that first off, it began with a question: what is creating these emotions? If there are two separate things, and one is my mind and what is my true self, what is creating the emotions that I feel? And so I went deep into the nature of emotion and the various different types of emotions and how they manifest and like how come to be, and what I feel when I feel them, and what each emotion is. And as I got deep into them, I realized that all of these emotions can be separated into 5 different groups. And that the emotions can be either they can be a part of who I am, they can be a part of my true self. I am emotion, and I exist within the present moment, or they can be mind-made. They can be mind-made emotions. They can be things that my mind has come up with. So as I'm thinking through this and kind of realizing and being able to have some emotional awareness and emotional intelligence about what is the nature of these emotions that I'm creating, well, some of them are present moment emotions. They're always here. I can always find those present moment emotions. Those are part of my true self, my spiritual self. And maybe that's peace. Whereas happiness and sadness comes from my mind. It comes from me judging some external, thing as good or bad, and it creates this happiness or sadness. So my mind, through judgment, is creating happiness and sadness, whereas peace is within. Peace is present moment. Happiness or sadness is always a past or future emotion. And I feel like this ties into our conversation actually pretty nicely. But then, there's all these other mind emotions, of course, other than just happiness and sadness. And the boxes that they fall into, there's really 4 of them. So it's past and future, positive and negative. And so when I look at past, I can have past positive or past negative. When I look into the future, I can have future positive or future negative emotions. And so past negative, when I've judged something from the past as bad or wrong, it comes off as a past negative emotion. So sadness, or if I spew on that and I never let it go and I'm constantly going back to the past, then I create depression, which is like a sadness on steroids. It's my mind going through these patterns of creating it and not letting go of it. Past negative might also be resentment. Past positive might be, thinking back on a situation fondly and experiencing, some pleasant emotion like happiness. Future negative might be anxiety. It might be fear. When I'm thinking into the future and my mind is creating an imaginary future, it's not real, it's not here, it's not in the present moment. But when I'm creating an imaginary future scenario, I create anxiety. I create fear. On the negative side, when I'm looking forward to some event like this podcast, when I was looking forward to this podcast earlier, I'm creating anticipation and excitement. Whereas present moment emotions are joy and peace and curiosity, openness, playfulness, all of the things that are just a part of who we are as a life, I think, exist within that spirit that we are. And it's not until our mind judges something from within the matrix that we create these other emotions, and that's why I say ego or anger is an ego repair mechanism. Anger is an emotion that we create after judging something negative, and it's designed to repair our false sense of self. It's, our mind, our unobserved mind is really the ego. So I feel like that revelation, I want to write a book about it, but now that it's out there, I'm sure somebody will just, AI write a book about this for me and get it out before I can. But I figured I'd at least put that out there as an interesting kind of tie-in to consciousness and the nature of reality and how we kind of create things through our minds about the nature of reality. And if this was a matrix, if this was a computer simulation, we're all mistaking our true selves for our minds. We're all, that's the hoax. That's and I think that goes to your point back to every ancient tradition and ancient mystic and even the basis of religion, really of all religions. I mean, Jesus was a mystic. The Buddha, I think, saw this clearly with dukkha. Christianity sees it as liberation, and salvation. Every religion has a way to describe kind of freeing yourself from your mind. That's why that Matrix movie, taking the red pill, free your mind is so compelling as it relates to this topic. So anyway, as you were talking and thinking about talking about the emotions and talking about free will, it kind of struck me, and I felt that correlation to true self versus false self. And false self could be described as ego. It could be described as the unobserved mind. It could be described as your movie character within the Matrix, you know.
Right.
But I thought that was interesting and kind of wanted to get your thoughts on that.
Yeah, absolutely. I think, you know, for me, I like to use this analogy. And this is where we get into the Matrix as metaphor, where the player is the spiritual part of you that's outside, and the character is your current life and your current ego. And there is a kind of narrowing, if you will, that has to happen before you enter your avatar, is what it's called. So the term avatar actually came from ancient Sanskrit. And what it means is when you have a divine figure who decides to squeeze themselves into a human body. So there's like this narrowing that has to happen. And so one of the first online multiplayer games, we wouldn't call it a massively multiplayer game because it was pretty early on, was a game called Habitat. It was built by Lucasfilm, so George Lucas's company. They also, you know, this eventually spun out Pixar, so they were doing a lot of stuff with computer graphics. And so these guys had built this game, and he used the Commodore 64. I don't know if you remember that computer, but it was you know, we used to have one at home, and a modem dial-up lines, and then you would have a little character on the screen. And they were like looking for a name for that character. What do we call this character that you play? And they said, well, it feels like I'm taking my whole self and I'm squeezing myself into the phone lines and I'm into this little 2D character. And so they end up borrowing the term avatar, you know, for your character within the game. But I think also, you know, we have a certain amount of conditioning as we go through life. And sometimes we're reacting from that conditioning, and we are not in touch with our spiritual selves. And I think, so I have this new terminology. I mentioned NPC versus RPG, but there's this in between, which is NPC mode. Like we're going into NPC mode when we're just reacting based upon everything we've been trained in this life. It's like an LLM, a large language model or a neural network that's been trained by the experiences in this life. But then when we remember, whether it's through emotions like peace, or we just remember that there's a part of us that is bigger than all this. And for me, this is why the video game analogy works so well, is in a video game, you choose, you know, what character you're going to be. You choose your avatar from a set of choices. And this is just like we used to do with Dungeons and Dragons. We used to do it with character sheets. And you would choose a race, like an elf or a human, and you would choose a profession.
All parts of the false self.
All parts of the false self. And, you know, you would roll some random numbers to get attributes of you, like, you know, intelligence, charisma, physical attributes. But then, most importantly, you would choose a storyline. And the way that games work now is you have quests and achievements. And, you know, you would choose based upon your level and your level of a character, which quests are open to you. But also the difficulty level, you know, might be really high. And so you might have an overall storyline when you're in the game, but you know, you might have a sense of it, but then you have the individual challenges along the way. And so this becomes a way for us to think about our time here in the small or the false self, as you said, as being a character with a storyline. We're still free to make choices, but perhaps there's a reason that certain challenges and difficult situations come upon us. And
it's life giving you an opportunity.
It's life giving you an opportunity to experience those challenges. Now, people always say to me,
and to grow from them.
And to grow from them. And that exactly, people say to me, what's the purpose of the simulation? And I say, well, what's the purpose of playing video games? Well, you want to have fun, but to have experiences that you may not be able to have outside of the game. And you know, that's where I think it ties to this idea of coming into this world to experience and to grow and to learn from it. And the nature of the game is revealed by how you review it after the fact. And people who have near-death experiences often report the being of light, before they go in their life review. They ask them, okay, so what did you do with your life? What was it you were going to do? Right? So there's this element of a life preview sometimes where they were supposed to do X, Y, or Z. And did they grow from those experiences? And I think that's interesting as well. And it provides us with a different perspective on life. There's a saying in the video game industry, which I think was coined by Nolan Bushnell, who was the founder of Atari, which are the games that I played when I was a kid, like Space Invaders and Pac-Man. And he said, make the game easy to play but difficult to master. And why? Because if it's easy to play, everybody will play it. But if it's easy to master, people will get bored and they'll stop playing it. But if it's difficult to master, they'll want to keep playing it. Now, if it's too hard at the beginning, then people will abandon the game. And I think of life as a series of difficult challenges and within our storyline. And I personally believe that we all have our storylines, and that they're what help define us separate. So, for example, if you had asked me in high school, what I was going to do with my life, I would have said, well, I'm going to be a computer software, entrepreneur, and then I'm going to be a writer. Now, all my siblings had the exact same upbringing that I did and pretty similar genetics, and none of them wanted to be a writer. And so that was sort of my storyline. And somehow I had an intuitive sense of it. And that's eventually what I did, although, it took a lot of twists and turns to get me there. I thought I would become a full-time writer at what I considered an old age of 28, back then. But of course, I didn't. I did start writing my first book at 28, believe it or not, which was Zen Entrepreneurship, which was about my experience with weird phenomena and my experience with starting a company. But it wasn't until I was 48 that I really devoted my energies to writing books. And that came about because of a personal tragedy that I had at the time, which was a health issue. And I ended up having to have heart surgery. So I was sort of at the height of my entrepreneurial career. I had sold my company, had, made a lot of money, and I was at MIT, and I was running this program for startups. We were bringing people from around the world to MIT, as well as MIT students who wanted to start companies and video game companies. And at that time, I was following what I had kind of picked up as the Silicon Valley storyline, which is, you make a lot of money, you sell your company, and then you become a venture capitalist, and then you start a venture capital fund, and you raise a big $1 billion fund. Like you get caught up. And I think we get caught up in our environments, right? Whether you're in Wall Street, you're in Los Angeles, or Silicon Valley are three kind of good examples. But you get caught up in what other people are thinking. But it was during my heart surgery that I had a series of insights. And it wasn't sort of a traditional near-death experience in the way that some of these folks have described it, but there are variations on the near-death experience. And in my case, it came as a series of visions. And one of the messages that came across very strongly during those visions, while I was recovering, I would just fade in and out of consciousness because I didn't have much energy. And the message that came across very clearly was, hey, you had a storyline. You were supposed to do this, be in Silicon Valley, do the entrepreneur thing, and then you were supposed to become a writer. And here you are, you're 48 years old, and you're still working on startups and making money when you were supposed to have turned your attention to something else. And it turns out that particular personal tragedy made it impossible for me to keep doing what my conscious mind wanted to do, which was raise a big VC fund to keep doing. Because what would happen is every time I would jump back into doing some business opportunity, I ended up back in the hospital. And then I ended up having to get stents in the heart. But I had just enough energy to take an Uber to the local Starbucks and do an hour or two of writing every day. And in 9 months, which is about the time it took me to recover, it took years to fully recover, but at least to recover to a normal pace where I could do normal things like go for a walk. That's a long time. But in that time, I published 2 books. one of which was a set of lessons I learned in the startup world. But the one that I really focused on at that time was the simulation theory and the simulation hypothesis, which brought together these different threads of my life to that point in time. I always tell people, to follow their curiosity. What is it that makes their curiosity unique? I was always intrigued by things like out-of-body experiences and glitches, but I was also intrigued by technology and video games. And so this allowed me to kind of complete my storyline, if you will, and bring together all the different threads. And science fiction was a big part of my interest. In fact, my PhD is in how does science fiction actually influence technological innovation. But I was able to bring in these ideas from science fiction and simulation theory all together into and synchronicity. I had written a book on synchronicity as glitches in the Matrix, and I'd even used that terminology even before I had gotten around to coming up with the conviction that we live inside a simulation. And it turns out it fit pretty well. So I think that's what makes us all unique, is that we have a storyline that, just like in a video game, that we have planned for ourselves. And it makes it, whether you believe it or not is up to you, but it makes it, I think, easier to deal with the challenges in life. When we have something bad happen to us, perhaps, it was part of us. I like to think of it as a writer's room that perhaps is sitting there and watching the episodes of the show. So they're watching what we've been doing and saying, okay, now this character has gone through that. Their overall storyline was this, but let's now introduce this challenge or this quest with, sometimes we meet people and there's something we need to do with them, whether it's a business challenge or a relationship or a personal relationship or somebody we hate immediately, whatever the case is, somebody that pushes us as a mentor, as a relationship. And I feel like there's a part of us, which is the spiritual part of us that I call the player, that is watching it. And so this idea that near-death experiencers have a being of light and they're reviewing their life is something that we're doing all along. We just don't remember it because it happens when we're outside of this kind of very limited false self, if you will.
Do you feel like the last question, and then I'd love to maybe take a quick break and I want to talk about UFOs maybe after the break, just to close it out. Do you feel like if this player is being reviewed, not judged, but reviewed by this being of light, this all-powerful, all-loving, all-encompassing being of light, that the player itself could also be actual light?
Yeah,
the spirit that we are. Could the spirit that we are be light?
It absolutely could be. So people often ask me, okay, what's outside the simulation, right? So these are questions that I get asked. And I don't take a strong position on that. I think a lot of the materialists would say it's an actual physical universe, kind of like in the Matrix when they got out. I tend to think that it's at some level, whether it's immediately outside of this one, it's also been suggested that the world that near-death experiencers see is, one, more real, but two, they'll see things that are also kind of a simulation, if you will, that based on where they are spiritually. Some people will see Jesus. Some people will see, a different spirit. Some people will just see a being of light. Some people will just see a garden. Some people will see a crystal city. That perhaps all of that is also another kind of simulation that's outside of this simulation. And when I had my I call it my halfway experience between life and death, because it wasn't like I actually got to the same point that people who are declared clinically dead, but it's like I was in this halfway state. It was, to me, it appeared, and I haven't talked about this much really on any podcast. And at some point I will write about it more, but to me, it appeared as if it was like a Buddhist monastery with these Tibetan monks. And it became clear to me, the more visions I had, that they weren't really Tibetan monks and that this really wasn't a monastery, that it was just a fabrication that was meant to make me feel comfortable that these are more advanced beings who are spiritual beings of a different type, whose task it was to help nurse me back to health, kind of a convalescence, if you will, but also to give me the insights that I would need for the next part of my life. But I do think at some point as you go outside of that, we are non-physical beings, which I think would lead to the conclusion that we are light. So, that's my personal opinion on that. But I think if you look at what the mystics have been telling us, it gets back to if you look at science fiction, one of my favorite science fiction movies is The Empire Strikes Back, and everyone remembers Yoda tutoring Luke Skywalker, and he says to him, "We are beings of light, not this crude matter." Right? And I think that is a good way to think about what the ultimate player is.
Okay. Yeah, cool. Love it. Love it. Yeah, Avi Loeb disagrees, just for the record. He he does not think that, because I asked him that question directly. But
yeah, and I know Avi, and I'm involved with the Galileo project.
Right.
And, he's also, at Harvard in an academic environment. And,
Sure.
and I've studied, how academics think about things. And there's a certain point of view that they need to have, I think, to be successful in that world.
Sure. Yeah, for sure. Well, good. Yeah, if you're cool, I say we take a break, get a quick bite to eat, come back, finish up with UFOs, and call it a day.
Sounds great.
All right, cool. Well, cool. Well, then let's jump back in, and we'll jump back into the topic of UFOs and how they relate to this thing. So where's a good place to start with that?
Well, I would say that, UFOs exhibit very strange behaviors. And the phenomena itself, whether you're talking about craft or you're talking about beings that people have seen, there's a whole spectrum of the phenomena. And I got interested in it many years ago, and I thought it was just a nuts and bolts type thing. And, there's this question of, are UFOs just human craft made by the government? Or are they aliens from another planet? And generally speaking, those are the two options that get considered. I wrote an article for NBC News a few years ago saying the government takes UFOs seriously. Why doesn't Silicon Valley or academia? And in that article, I talked about the potential technological implications of craft that could be from other planets, but also maybe from other dimensions. And the editors were like, well, that's getting too complicated. We just want it to be either aliens or nothing. And if you look at the framing in a lot of headlines, they tend to try to simplify it in that way. And I think our understanding of UFOs is influenced very much by our science to date and the science fiction we've seen to date. And so when we see unexplained phenomena, if you went back to the 1950s or 1940s, people saw unexplained phenomena like UFOs. They assumed they were from Mars, and people who claimed to have had contact with strange beings would say the beings told them they were from Venus. Right? And now we know, I think, it's unlikely that there's humanoid beings walking around on either Mars or Venus. Perhaps they're hiding from us, but assuming that there aren't, what it shows is how we interpret phenomena based upon our filters. And our filters are determined by both our science, but also by our stories and narratives. And just as in ancient times, if they saw something weird in the sky, like a round object, they might call it the chariot in the sky, going back to the Bible. Mm-hmm. Or if they see a being, they would assume that must be an angel or a demon, right? Because those fit into the dominant narratives of the time. And to a certain extent, everybody raised during that time, pretty much shares that narrative. And I think the same is true with UFOs, is that we tend to say they're either, we live in a techno-scientific age, and technology has become very important. And so they're either technology the government has created, or they could be from aliens, because we happen to know there are other solar systems. In the same way, we didn't know if there was life on Mars. We don't know if there's back then. And now we don't know if there's life in these other solar systems, but there certainly could be. So we interpret that as being aliens. Now, whether they are actually aliens or not, I think is an interesting question. But there's aspects of the phenomena that I think are worth looking at, which show that they are both physical and non-physical. And so I spent a lot of time talking with Jacques Vallée, who has been researching UFOs since the 1960s. He was part of Project Blue Book, and he was the inspiration for the French scientist in Close Encounters of the Third Kind. He told me about a couple of incidents that made me think about the overlap between simulation theory and UFOs. And he said that in some cases, a UFO would appear and one person could see it, and the person next to them could not see the UFO. And now that doesn't make a lot of sense if you just take a purely materialistic point of view. Even if you say they're aliens from another planet, why would one person be able to see it and the next person standing next to them? And similarly, Gary Nolan at Stanford, who runs the Soul Foundation, which I've been involved with, I wrote a white paper for them, has told me about incidents where one person sees a donut-shaped object, and the person sitting next to them in the car, in the same family, sees, a round object, a cylindrical object. So you've got these vastly different shapes, but they both have pretty much the same perspective on it. And so that shows to me that there may be a phenomena that is similar to what we do in video games. And so in video games, if you and I are in the same room, it might seem to us that, or say we're standing in the same field in World of Warcraft. The reality is we're not standing in the same field, right? My avatar is being rendered on my computer or in my virtual reality headset if we were doing a VR game. And your field is being rendered on your computer. So these are different devices. And if you're playing Fortnite, it might be rendered on an iPhone or an iPad. So each of us has our own rendering device. And what gets rendered is based on information about our character, but also that's sent from the server. So you could easily look up and say, because if you're level 30, you could look up and say, look at that dragon that's flying over the castle. And I could be there saying, I don't see a dragon. Right? There's no dragon there. And what it shows is that there may be this possibility of conditional rendering with a phenomenon that's as complex as the UFO phenomena. And what that means is some people might be able to see them and other people may not be able to see them. And many UFO experiencers have said they felt like the UFO was communicating to them in some way and they were looking at it. So there's something going on there that I think would lend itself to this idea of conditional rendering, if you will. So that's one overlap between simulation theory and the UFO phenomena. I think another interesting case that Jacques told me about was, he said he was investigating this case. I think it was like Northern California or Oregon. And, if you've been to that area, they have lots of redwood trees. And he said that the witnesses said there was a UFO that came down at a 45-degree angle and there was a clearing and that it had landed there and maybe it had left some marks or something. And, he went back to the place with them after all the other investigators had left. And he said, explain one thing to me. If it came down at a 45-degree angle, it means it would have had to gone through the trees. And they said, yeah, it did. But we don't want to say that because we would sound crazy. Now, that's an interesting, I think, another clue that I'm not saying UFOs aren't physical, but they seem to go in and out of the physical world. And when in a video game, when you're rendering it, there's a period of time where the walls are not solid and you can render something and it gets rendered as kind of a wireframe and then finally when it's fully rendered, it becomes fully physical. And now it has to obey all the physical laws of the universe. And I've had other witnesses tell me they're looking up and there's nothing there, clear blue sky. And then suddenly it's like a UFO materializes up there. So I think there is this element of materializing and dematerializing that is similar to how we would render inside a video game, where if I portal from one place to another, what happens is I just show up in that and then I render itself. And then finally, some of the movements of UFOs as they've been reported tend to suggest that it's almost like it's light moving around. It's moving around so quickly, almost like if you had a laser. Not all of them, but some reports say that as well, which again shows me that there is this element of light rendering something that becomes less physical than what we think of as physical. And of course, the whole point of the simulation hypothesis is that which we think is physical is not really physical at all. So those are a couple of the areas of overlap between simulation theory. The other area is this idea of avatars and how we view these other beings. So I mentioned interpretation, but there's also this possibility that they are presenting themselves to us as a technological phenomena or as beings that are like gray aliens, with the big eyes, but that may or may not be their actual form. And so a number of folks have speculated that what we're seeing are the avatars of these other beings. We're not actually seeing these other beings, which means they're being projected down into our reality, either from outside of our reality or perhaps from another part of our reality, but they're so far away and they're using information to send it and to control these sort of AI renderings, if you will. And so this is, this idea that we are seeing a being and we're interpreting it as alien, but maybe it's similar to beings that have been reported here all along. So if you go back to like in the Celtic folklore, or you go back into the Islamic folklore, you have the jinn, who are another class of being that are supposed to be here on Earth with us, who we can't normally see, but they can see us and they can come in and out of our reality. And people, it's interesting, some of the abduction stories that I've heard, and again, UFO phenomenon is also a spectrum, right? There's some things that are easier for people to talk about in government and the other things that gets a little woo and gets into psychic phenomena and all of these types of things. And abductions is one of those areas that even a lot of the scientists who are studying it don't want to talk about because it just starts to get really weird. You've got creatures coming through walls as if they're non-material, but then they materialize again and they're taking, people up there. And I've heard stories that if you go back in the literature, you find similar stories in other times. And Jacques, wrote about this in some of his books where he talks about the Fae, which we refer to as fairies today. We think of it as these little things, but taking people into the world of the Fae, and you had to be careful. And, stories of, some of them had what was like a wand that could be used to immobilize them. And I remember reading about that. And then later I went to the Archives of the Impossible at Rice University. Jeff Kripal there runs the program, and they have all the letters from Whitley Strieber, who wrote the book Communion. And for many people, that was the first time they had seen like that kind of typical gray alien shape on the cover. And they're like, oh my God, that's familiar to me. And so people would start writing him letters. It's really fascinating seeing these letters actually, because this was back in the 80s. So they were like, in many cases, they were like 12-page typewritten letters where people hand drew things. And one of them hand drew what would look like a gray alien, but with a wand, and talk about how they use this, or a rod, to immobilize, which is a certain type of technology. But I wonder if it's also possible, one, that these beings have been here all along, and two, they go in and out of our reality and get rendered in our reality. And I was saying that sometimes you can see stories that are so similar to stories from today. Like I remember Whitley Strieber talking about a story where there was a young man who met this young woman, and it was his girlfriend, and they had sex, and she called him up to tell him she was pregnant, and he thought they were going to get married. And she said something like, "Oh, I have something I have to tell you. I'm really a gray alien. I'm not a human." Now, this sounds kind of ridiculous to those of us coming at it from a scientific point of view. And she transformed into what looked like a gray alien, and then she transformed back into her human form. And she said, "I'm taking the baby, and I'm going back to my people, and you'll never see me again." Now, some people would say, well, that's just a bad breakup. She just didn't want to talk to him anymore. Right? But what was fascinating to me was I was reading a story about the jinn, and it was very similar. It was so similar that it was uncanny, from medieval times. And he said, in the story, there was a man who married a jinn woman, and they had 2 kids. And one day she said, "I'm taking, the kids back into the jinn world, and you'll never see us again." And they just disappeared. And it was just so similar to what we're hearing about today that I began to wonder, is it a case where these are other beings that are here that get rendered as avatars into our game? Or there's also this idea of ghost mode in video games, where you can see what's going on in a room, and you can actually be there, but your avatar is only like a little dot, so nobody can see you. But you can see everything because you're seeing it on your screen. So I think a lot of these areas overlap with both traditional stories as well as with simulation theory. Not to say that I don't think some of these stories and some of the UFO phenomena could be extraterrestrial. I mean, I've talked to enough people to believe there is something to the phenomena, just like with near-death experiences. Once you get beyond a certain point, you realize there's something there. But what it is, I think, is something we can discuss.
So if there's a lot there, I guess first off, when the tree thing and a UFO traveling through the trees in California, the big redwoods, or something walking through a wall, trees are matter, and just like us, they are 99.99999999996 empty space.
You got the exact number. Yeah.
So it's, I mean, they're almost entirely empty space. So it's very easy to imagine that some advanced species could figure out a way to just casually fly right through that or walk right through that, just align the empty space up with the empty space and not have any of the molecules collide or the atoms collide. Now, on the question of UFOs or extraterrestrials specifically, maybe as it relates to the simulation, if this is a simulation and people are seeing UFOs, then there's only a couple of options there, I think, and that's that the creators of the simulation are putting the UFOs into the game, which would be one, or the UFOs themselves are a part of the same simulation that we're a part of. They're just from another part of the game. Because if it's anything other than that, I don't think there's any other maybe I'm missing something, but I think those are the two possibilities, because if they're showing up and people are seeing them and people are seeing the ships and they're seeing the little aliens, either they were put here or they're a part of it, right? Or they're the creators themselves, potentially, but if they're extraterrestrials, then I guess that implies they're not the creators themselves. But am I missing something, or are those basically the options?
Well, I think those are, two of the main options, which is they're from somewhere in the simulation, which could mean another planet. I mean, there's no reason a simulation would have only one planet on it, and they could be extraterrestrial, but they could also be from part of the simulation that we aren't able to see, right? So we may only be able to see a part of the simulation, and there may be other beings here on Earth with us. So the other possibility is sort of what's called I think Hal Puthoff called it the ultra-terrestrial model. And others have said there's actually another term, which is the Silurian hypothesis, which is a term that comes from Doctor Who. So it's like a science fiction thing where they had a reptilian race that was on Earth well before us. And they had gone to sleep for like 1 million years or something like that. And they were underneath the Earth. So another possibility is that they're from another part of the simulation, but they're here, whether they're hiding from us, or they literally are in a space where we can't see them, in the sense that that part of the simulation is not being rendered for us, but it could potentially be there. Another possibility.
I think that's the same one, though, right? That's the same possibility that they're from the same simulation. They're extraterrestrials from the same simulation that we're in. Whether we can see them or not, those are just details. But
right. Well, it could be, yeah. It could be that they're in the simulation, but we can't see that part of the simulation. So this gets back to my idea of like the jinn, or the fae. Like they have another simulated world that is connected to this world, and they can come in and out of this simulation. So that's another possibility.
Like a dimension, like a spiritual dimension or something?
Could be a spiritual, it could be another like physical dimension that could be thought of as either a parallel simulation or part of the simulation. I mean, you can go back and forth on this in a lot of different ways, but they could be running it with the same parameters, and they're aware of what we're doing because they're affecting each other. But normally we can't access that part of Earth. So in that case, I'm saying they might actually be here with us, as opposed to being hidden underground, which means they're like kind of same as us, physical, but we just can't see them because they're down there or wherever they are. But I'm saying there could actually be another part of Earth that if you're able to get into certain states of consciousness or certain states of electromagnetic radiation or certain states of frequency, that you could see, like they're here all along. It's just that we can't see them.
But people are seeing them, right? So I mean,
sometimes they see them, but not all the time.
No, that's not. I mean, the basis of my question is trying to get at the nature of reality.
I see.
And so, like what? So we've seen them, so we know they exist. Enough people have seen them. It's like the comment earlier that if enough people say that they've been to China, then China's real, right? So if enough people have seen, or if enough people have had near-death experiences, then near-death experiences are real. If enough people have seen UFOs, then UFOs are real. So they're here. People have seen them. Let's just operate under that assumption. Whether that's 100% truth or not, let's operate under that assumption. So what are they is the next question. And so if we ask that question, it seems like they're either a part of that they're a part of the simulation. They're either the creators of the simulation, or they're a part of the simulation, or they're placed here by by the simulators, by the people who have created the simulation. I think those are the only options. And if we dive into each of those three things, then certainly if they're a part of the simulation, whether it's through another dimension or whether it's in some part of space in the universe that we can see, or some part of space in the universe that we can't see, wherever it is that they came from, they're still a part of the simulation. They're still more, they're characters like us. They're biological beings within bodies that have made their way to Earth somehow. I think that's a big one of the possibilities, and I feel like there's a lot to that, and certainly they could be hiding, certainly they could be underground, certainly, there's a lot of details and minute kind of, things that can go along with figuring out that possibility. But I feel like that's one of the big kind of maybe two or three possibilities for what is real, that they're a part of the simulation with us, and that they've made their way to Earth, and that people have seen them and people have interacted with them. And again, who knows if they came from another planet, from another dimension, or whatever it is, but that they are a part of this simulation that we're in. So, thoughts there? Yeah,
no, I mean, it's a good point. I mean, I would separate out those two because I feel like, at least from our modern technological and scientific society, being from another planet is something that we can grasp easily because we know of these other planets, but being here and being invisible from us, what does that mean? That gets into a lot more complexity. So I would say maybe it's a slightly different scenario. Another scenario that's in between the two is this idea that they could be time travelers from our future.
Right.
And they're coming back to the past. Now, again, what does that mean? Now, from a simulation theory perspective, one of the things that I've talked about is that if you can run a simulation, you can change the variables, and you can run it again. You can change things. And each time you run it, that ends up defining a timeline. So it's possible that they are from the same simulation in a sense, but it's a different run of the simulation, or it's a future run of the simulation.
This is Mike Masters?
Yeah, so Michael Masters, who's at Montana, is it Montana Tech? It's somewhere in Montana. And he came up with this idea, theory that's called the extratemporal model, or extratemporal, depending on who you talk to, where they are actually us, but we've evolved in a certain way. And he's coming at it as sort of, anthropologist or a biologist, looking at evolution and say, what would happen to us in a couple million years if we continue starting from, when we were apes, we had a lot more hair, we have more technology now, we're less, say, physically robust than we used to. And if we just keep focusing on our minds and our technology, it's possible that our heads could grow bigger, our bodies can atrophy. And then if we end up living underground or in the dark, it's very possible that our eyes would grow bigger. And so that remains an interesting possibility. But in a simulated world, time travel is possible because you can just stop run, you can go back and start rerunning it from a saved point in time. And so it's possible that they're trying to influence us somehow. if we take the assumption, as you said, that they're here, and some of us have seen them, now what are the possibilities for why they would be here? One is they're just exploring. Two, they want to take over the planet. This is the Independence Day scenario. So if they're not just tourists and they're not really conquerors, what are they doing here? They're probably here to influence us in some way. And again, if you take the stories seriously of people that have been abducted or that have had contact, many of them expressed concerns about the state of the planet and are we going to destroy the planet, kind of environmental type concerns. And they've shown videos and things to people, videos in quotes, because whether they were actual videos or somehow they were movies that they were sending through the mind about that scenario, that would make some sense as well. I mean, I also think that if they are extraterrestrial, it's very possible that they are AI. They're not actually like us. They're more like AI beings that have been manufactured for long space trips. So depending on the technology. Now,
not biological. So
yeah, they could be biological, but grown biological, if you will. So kind of like our AI NPCs, if you will, in a sense.
So in a simulation, why would aliens tell us that we're destroying the planet if it's all just a computer game?
Well, if in that scenario, I was going down the path of the time travel. So it may be possible that they are us in the future and they want us to change the timeline to do something different. So that's what I meant by they're potentially trying to influence us so that we don't become them. Now that's a theory. Obviously, I don't know for sure, but that would be one reason why. Now, if they're aliens, it could be that they're just more advanced aliens who've been through this process before. It gets back to, bigger questions about what is the purpose of the simulation. And, it could be that we're running the simulation to see what will happen in this part of the simulation, but there could be other species which have been running much longer than us that have been doing this for 1 million years more. Again, we're back in science fiction land. There's a science fiction writer named Ursula K. Le Guin, and she wrote a series of stories including books called The Left Hand of Darkness. And there's this kind of 1 million-year-old civilization that, has kind of been all over the galaxy. And the only thing they really value at this point is the cultural knowledge. So they're kind of like anthropologists in the same way that, if there might be a tribe that's still living kind of a Stone Age existence. Maybe we value their culture because they don't necessarily have any technology or anything. That's more, that's that interesting to us. But their stories, their views about life and death and all of that, their shamanic practices maybe are more interesting. And so that's a possibility too if they're coming from another part of the simulation. Or maybe they destroyed their planet and it's not our planet. It doesn't have to be the future, but they're coming here as kind of an old elder brother. Now, that's the opposite of the threat narrative, right, which has taken a hold recently, is that, are they here to basically at some point take over the planet, or they're farming us. I mean, you get into all kinds of crazy conspiracies, I think, when you go down that road, which starts to become interesting. I mean, we talk about the Matrix. Possibility, yeah. So at that point, we're kind of in a lot of speculation mode, yeah.
Okay, yeah. I mean, it seems like there's a ton of evidence for it, and then when we get to the UFO thing, it doesn't totally jive for me with simulation, for whatever reason. Like, I guess, like, scientifically it does, and with all the other stuff that we talked about, it does. And then the UFO thing, it doesn't mean that it's not a simulation. It's just like, if it is a simulation and there are these extraterrestrials and there are these aliens that are visiting us and that are here now and that are interacting with people, like, how do they fit into that simulation is what I'm trying to wrap my head around. And certain, so I'm hearing for sure could be a future human, but future human in a civilization, I guess I'm having a tough time with. And if it's an extraterrestrial within the same simulation,
Sorry.
Yeah, go ahead.
Think of like a multiplayer game, right? Where or like an Empires game or
Yeah.
Risk. Like let's go back to board games.
Well,
So-
the game Civilization itself, where you
Yeah.
start on different parts of the map and you come
Exactly.
meet each other.
And you come meet each
Yeah.
other.
Well,
And-
that makes sense from an extraterrestrial standpoint.
Yeah, and I think
Mhm.
that from the extraterrestrial standpoint would make a ton of sense because different planets will have different sets of challenges. And then eventually it gets back to what is the point of the simulation? Is it to see if these civilizations ever meet? Is it that we've got a simulation where it's so difficult to travel these distances that we wouldn't meet for a long time? So it gives the ability to develop independently. I mean, one of the aspects of simulation theory that I find interesting is there's a term called computational irreducibility. And it was defined by a guy named Stephen Wolfram, who studied cellular automata. He also wrote the Mathematica software, which was really popular with engineers. And, he thinks the whole universe is a set of computations. And he came up with this term because he said there are certain processes where you don't know what's going to happen unless you run the whole process. So if you want to say what's going to happen at step 2000 or 2 million, you have to first get to step 1999. And to get to that point, you have to go to step 1998. And so you have to basically run it. And that's true even for deterministic processes, even if there's no free will. Like the three-body problem is an example of a potentially chaotic problem where you've got these three, let's say, suns or planets, and they're rotating around each other. And the question is, will they stay stable, or will they at some point in the future, will one of them shoot off? And as of now, I mean, there was a science fiction novel in a Netflix series called The Three-Body Problem. But part of it was because I think the aliens in that case were from the Centauri system, which has like 3 stars. But we don't know the solution to that problem. And the only way to get there is to actually run the simulation. And so it's possible at a civilizational level, the simulations are being run not just for us individually, so we have a personal level of why we might be involved in the simulation, but then there's the bigger civilizational aspects to see, will we pass the great filter? Will we get off the planet? Will we stay here until there's an asteroid? What happens to the civilization? Will we destroy the planet? Are there other things that we will figure out, like how to create sub-simulations? Right? So when you get into that level, then it makes a little more sense that you might have separate civilizations to see, how far they get before they interact with each other, because the simulators would like to see how it goes. But I think back to your other point, if the creators of the simulation are placing them here, I would still say that there is a subjective or perspective that we're getting on these things, and it's possible they are placing them here in ways that make sense to us. And like if you look at sightings that happened in the late 1800s, they called them airships. And so there's a whole thing about the airship sightings mysteries of like the 1890s. Well, they knew sort of what an airship was because they had the balloons, right? Dirigibles and stuff. So it was interpreted that way. And I still think perhaps we're seeing this UFO phenomenon. We're interpreting this as spacecraft, when in fact, that's not what they are. They're just being presented. Like in a video game, you can change your appearance. You can change your avatar. Even the gray aliens, they're being presented to us as aliens because now that's something that we understand, but they're actually some other kind of being altogether. But it's so complex that we wouldn't be able to get our heads around it. We can get our heads around aliens, just like the Mars-Venus example I gave you. There's a deception going on, I think, which again gets back to Jacques Vallée's theories on those. That said, I have been told by people that have been in these programs that there is an element of extraterrestrial with the UFO phenomenon, but that there may be other aspects to it as well, which involve consciousness and how we perceive things and other beings that maybe are not purely physical beings.
Okay, so I mean, what are the possibilities in your mind that this simulation is that we are the creators of the simulation, that a future human is the creator of the simulation?
Well, so I think I like to list out the possibilities, and I don't take necessarily a strong position. So there's this idea of an ancestor simulation, which is that if we were to create like a game or a civilization, a simulation of the Roman civilization or of Greeks, then we are creating theoretically an ancestor simulation. And when Nick Bostrom first, defined the term the simulation argument, that was how he defined it, as future humans who decide to go back and simulate humans from the past. So it's not so much that they're future humans, it's that we are the past humans that they are simulating, because they're, from their perspective, they're in their current time period, which is far in the future. That said, when I look at it, when we make simulations in video games, we don't always create, humans that are exactly like us. I mean, we have elves, we have dwarves, we have dragons. We often create different races, and we create alien civilizations in these. So there's no reason, even if it is a physical-based reality, which is the assumption if they were future humans, that there's a physical-based reality that is creating the simulation. There's no reason why it has to be exactly like us. It would just have to be a more advanced physical civilization that is creating a simulation of us. And it could be that they're letting biology run wild to see what kind of forms evolve over time, although there does seem to be evidence of what's called the anthropic principle, which is that if you change a few variables like the gravitational constant, and there's 11 or so, or at least that many different variables, that if you change by 1% or 2%, the planets would fly apart. It would not be suitable for life. So it's possible that whoever's running the simulation is running multiple simulations, and they prune the tree to say, okay, these are the parameters that are more likely to lead to something. That said, even when we create aliens, we kind of make them humanoid, right? in our simulations, in our science fiction, like the cheesy alien costumes in the original Star Trek from the 60s, where it's just a guy with some ridges on his head, right? So we tend to make them kind of like us. So if it is a physical-based reality outside of this one, it's possible they're similar to us, but not exactly like us, I think. So that's one set of possibilities. I think there's also this possibility that it is a completely different kind of universe that is not physical like us, and they're not humans, they're non-physical entities of some type, at least what we would consider non-physical entities. And I think because that's where the overlap is with the spiritual and the consciousness side, is that you may have spirits that don't have problems, and they create the simulation as a way to get in and have some of those problems, because sometimes that's how you gain wisdom, is by going through challenges. And that's how you gain compassion, and you get all of these experiences.
Okay, interesting. Yeah, so let's get to that and maybe close out there then with the why. To what end? Why? What are the options for why? If this is a simulation, that it's been created in the first place. And so that would be one option, I guess, right? That it's a spiritual realm, and spirits want to experience the human experience, or experience the bird experience, or whatever it is that they're incarnating into. So that's a good option. What are the other possibilities for why this could have been created? Why someone would want to create this, either for others to go through or for them to go through themselves?
So, when people say to me, what's the purpose of the simulation, I always ask two questions. And the first is, why do we play video games? And then the second is, why do we run simulations? And I think those two questions get at different possibilities, actually. And the reason we play video games, well, first of all, is to have fun, right? But we also want to immerse ourselves in these worlds, and we want challenging experiences, because that's what makes the game interesting. Or if we have an actor with a role, they tend to win Oscars for the roles that have more difficulties within them. But in the end, it's to have experiences, whether it's us. And I happen to believe, that if you lean more towards the RPG version, that we chose to come into the simulation, and we choose to have these particular characters, and at least some of the challenges we choose to have. Where some may be random for probabilities, and then we decide whether to go through with those or not. Now, so I think that kind of fits that model that we just talked about, which is, to have these embodied experiences of a certain type, or to have, a mortal experience. there's a lot of great science fiction about this where
Immortal.
that we are mortals
Yeah.
in this. So we're going to die.
Right. Not immortal, but amortal
Amortal experience.
Yeah.
But who are the people who want to have a mortal experience? Immortal people. And like I said, there's a lot of great science fiction, including in like the Star Trek world, where you have these beings that are essentially immortal. Like they can stay alive forever. And
So that would be consciousness itself, I guess, right?
that would be consciousness itself.
Yeah.
That kind of is there forever. But there is something special and interesting, the way you experience the moment, getting back to what you were saying earlier about the moment and the emotions in the moment. But because of our mortality, you could view immortal beings actually envy us a little bit, right? Because if they've done everything, in a lot of this fiction, and there tends to be like these immortal beings who are like, they've done everything, they're bored. Like, what else is there to do? I mean, you literally have been around forever. So you have done everything. But if you're in a situation where you know your life's in danger or it's going to end, that makes it all the more valid or sweet or exciting or whatever the case may be that we may want to experience that, because you appreciate things more in that way, I think, as opposed to taking things for granted in that way. So that's a possibility as well. We can now shift to my second question, which is, why do we run simulations? And that is more of a civilizational question. We run simulations to see what is the most likely outcome of some process. And also, we try to optimize to say what is the most desirable outcome. What is the least desirable outcome? So we might run a simulation of, if you think of like early computer programs, you can run a fruit fly simulation, right? You only need a couple parameters. What's the death rate and what's the birth rate? And then you'll say at the end of year 1, this is how many flies there are, fruit flies there are. Year 2, this is how many, and you find that they die out if the birth rate isn't high enough or if the death rate is too high. And so now that's a very simple simulation, but you could run it at a bigger level to say what is likely to happen to this, this civilization. And you don't know until you actually run it. And if you're going to let people make choices, if it's not even just deterministic, if you're going to let people actually make choices, then you really need to run it to see what's going to happen. It's like the Pentagon running war games, on what would happen if there's a conflict in the Middle East, right? Something that's relevant these days. Or you're running virality simulations for viruses to try to figure out what's likely to happen. Or you're running other types of simulations. So you want to see what's going to happen. And then perhaps this opens up the possibility that you might tweak the variables and rerun it again and say, and this gets back to, we were talking earlier about how Philip K. Dick came to believe there was a timeline where Germany and Japan won World War II, but he became of the opinion that the simulators didn't like that outcome. And so they came back and they're rerunning this particular version. Or along those lines, there was, he came to believe there was a timeline where JFK was not assassinated in Dallas, but then he got assassinated in Orlando. Or maybe he didn't get assassinated in Orlando, he got assassinated somewhere else. Or then they ended up in a nuclear war. And so you run simulations at a civilizational level to see what will happen and if you change variables or tweak variables. So I think those are two very broad classes of why we might run simulations and why we might be here. Now, getting back to something we talked about earlier, people often say to me, I know this is not a simulation. You know why? I said, why? I said, because if it was, I would make myself a billionaire. I would make myself a Hollywood star. I would make myself, have all these great things. And my life doesn't have that. So therefore, I couldn't have chosen to be here in a simulation. And that's one perspective. But again, getting to the point of, where is the richness of life? What is the nature of the game that we're playing? I don't think it's Grand Theft Auto, right? Where that's what we're trying to do. I think it is actually that we are here to have experiences with our fellow players. In the same way that in World of Warcraft, you might have a guild, or in other video games, you might say, meet me at this place at 9 p.m. inside the virtual world, and we're all going to have this experience together. And there is some research along with near-death experiences, people who've been hypnotized to go back before birth, where they remember the time in between lives, like before they were incarnated here. And it's what the Tibetans would call the bardo, the in-between. And There's a great book called Journey of Souls from the 90s. And they would say how they would actually plan out with people that were meant to become their future spouses or business partners. Oh, I'm going to meet you here. And then those, they become little glitches or synchronicities or coincidences when we recognize someone that is there to remind us that, hey, we plan to have this particular adventure. Now, that can go into negative or positive experiences. But part of why in the ancient Indian traditions, they talk about Maya and illusion. But Maya means illusion, but it also means like a carefully crafted illusion, like a magic show. If you go to a magic show, you know the guy's not really sawing the woman in half, but that's what makes it exciting is the possibility that he is. And so you set up this illusion for yourself in a way to take it seriously, because that's where the richness is of life. I think that's my personal opinion.
Okay. Yeah. Fascinating. So ultimately to provide the experience, you're able to have that experience of life by creating the simulation. I mean, that's one of the options. So, and could that potentially be why the UFOs are saying that you need to take care of the planet better? You know, like the aerial school where the thing landed and 83 school children saw this being come down in a saucer and appear on top of the saucer and communicated telepathically with them and said, you need to, take care of the planet that you're on and not destroy the planet. And it was kind of like an environmental kind of a thing, because if that goes away, if the Earth no longer has the ability to support life and to be alive itself as a planet, then all of a sudden consciousness ceases to be able to have that experience of life, of physical life on this planet.
Yeah, I think that could be. I mean, that's sort of the group simulation, if you will, and that's our quest, is to see if we will destroy the planet or not. And
or ourselves, yeah.
Or ourselves.
Yeah.
We'll kill each other, or whether we'll get off the planet. I mean, I think part of the reason why UFOs
run from ourselves.
What's that?
Run from ourselves.
Run from ourselves. But part of the reason why UFOs appear as if they were spacecraft, could be because they're trying to encourage us to think about different ways that we might use technology in order to be able to travel to the stars someday. Again, like getting back to the airship example, somehow the technology seems to be ahead of us enough, but not necessarily a million years ahead of us, but ahead of us enough that, it could potentially guide us in the same way we're talking about the environmental message, could potentially guide us as well, I think. So whenever you're running a civilizational simulation, you have these individuals making decisions as well. And, how do you influence the individuals to work together to make decisions that would steer the whole thing one way or another? So I think that could be an interesting explanation as well.
Yeah, I'm much more convinced on this than I was prior. I don't take things to 100% or 0%. I try to stay open-minded on things, which is what I respect about your opinion on this as well. You're not closing up and saying that it's a fact even after all of your research. But I can see why this is something that people tend to not. People just kind of stay away from this one. They don't want to
the simulation.
Yeah. And it's because it's like you can think about it in your mind, and it's like, oh God, if I believe in that, if that becomes my reality through belief, then what does that mean? Like I've given up on life. I mean, what else is there? Why would I continue to be a good person? Why would I continue to want to get things for myself if this is all just some big computer simulated program and it's for somebody else's entertainment and I'm being watched and I'm being recorded? It's a miserable kind of like a reality to create for yourself. And that's why people don't create this reality for themselves. And realities that we create are just beliefs. When we take what we don't know and we add a belief on top of it, and we turn it into something that we know through belief. And so that I feel like that's why this thing it's not more accepted, it's not more studied, it's not more like bought into and believed in. It's because it's kind of a depressing place to put yourself, I mean,
well, it could be.
Yeah.
And I think, I don't see it necessarily as a depressing way, because I view it more closer to the RPG version than the NPC version. I think the NPC version could be a bit depressing, and we could say, well, nothing matters. You could be, nihilistic, at one extreme, or solipsistic, meaning it's just me and nothing else matters. Or you could say we're in a massively multiplayer game, and therefore how you treat other people is exactly the lesson. The personal goal of the simulation is twofold. One, it's to live out the storyline and the challenges that you have made for yourself. And so when there's difficulties, it can actually be encouraging, and it can be uplifting to think. I mean, what happens when you don't complete a quest in a video game? Well, you keep trying, you keep at it, you keep trying, right? And so you said this quest was set up for me at the level of difficulty that I'm at. And that's a different way of looking at being in a simulation, and that you're here with other people to have this experience together. So I don't think it has to be a depressing thing. I think it can actually be an uplifting thing and can get us through some of life's toughest challenges. And it has for me personally, I would say. Nice.
Yeah, I love it. But I guess the last thought that I had was just to ask you, last question potentially is just to ask you, have you considered that humans or that the consciousness that we are is being placed into this human experience as a way to achieve immortality, as a way to continuously relive and re-exist. And obviously, I think spiritually, science would tell us that we can't be destroyed, that we can't die, that there's no end, and so we'll always be there. But if we're not in a body, or if we're not in a physical form, then we're not having that experience with other people, and that experience of a self within a reality, and that connection that we feel with other people. Could this be a way for? That's why I kind of asked you about, could this be future humans that have created this simulation as a way to achieve that immortality and to never die when you die, and to continuously experience the human experience?
Well, that is a possibility. I mean, I think for future humans to create these worlds where we can live on, the question is, what state would that future human be in that would want them to come back and create these types of simulations? Would they do it as an escape from their reality? Would it be just curiosity, time travel? I mean, if you could time travel to any point in the past and live there, would you do that? Perhaps it's just a great adventure and people like to do it in that way. Or it could be civilizationally, they want us to do something different and they want to run the simulations to see what would happen. So it could be a way to continue living. But I almost view it more like, if you are immortal, you do this so you could be mortal. So it's sort of the flip of what you're saying. I think because of what we talked about earlier, it's that danger that something could go wrong, and that's what makes it exciting and fun in a game. I mean, if you had a game where nothing could go wrong, then that would not be an interesting game.
Right. Well, very good. It's been a great conversation. I really enjoyed it. Really enjoyed your time. I think by the time this episode airs, your book will have been released on what date is your book coming out?
July 22nd.
22nd. Okay. So this should be out on we'll try to get it out right around there. Yeah, the 24th or the 17th, I guess, would be the date. So but yeah, do you want to mention your book prior to signing off?
Yeah, absolutely. So the book is called A Simulation Hypothesis, and I mentioned the subtitle earlier. An MIT computer scientist shows why AI, quantum physics, and Eastern mystics agree we're in a video game. And the book should be available either for pre-order or should be out by the time this episode is out. And I encourage folks to go to their local bookstores as well. I always like to encourage, local retailers. And you can pretty much get the book anywhere. It's a new expanded edition. It's up to 400 pages and talks about AI, the recent developments, etc. So even if you have seen an older edition, it's almost like a new book coming out.
Love it. Good stuff. Really enjoyed it, man. It's great to get to know you. Great to meet you. Great job. Thank you for taking the time and really going into some depth on some of this stuff. So I know the audience will appreciate it. And Ryan, we appreciate you as well, man. Great episode, guys.
Yep. Thanks so much for having me here. This has been a lot of fun.
Great. Appreciate you, man.